Hello there, and welcome to Curious Snips. I'm truly glad you've joined me. Maybe you're settling under the weight of your blanket, eyes soft, the world fading just a little at the edges. Or maybe you're simply letting your thoughts drift like leaves on a quiet stream. However you've arrived, this is a space for softness, for wonder, and for rest. Tonight, we're beginning something gentle and grand, a slow and poetic voyage into the nature of reality itself. The question we'll be floating through over the next nights is simple, yet enormous. What is space-time made of? But don't worry, we won't rush. Also, we'll feel our wish, one thought at a time. This chapter is where it begins, with the stillness beneath everything. Before particles, planets, or people. Before even time, just presence. And just before we begin, if you're already feeling the calm settle in, I'd be so thankful if you gave this video a gentle like or subscribed. It truly helps more sleepy minds find their way here. And if you'd like to support this cozy corner of science a little further, there's also the Super Thanks button, and even channel membership. Every gesture is deeply appreciated. Now, if your pillow's ready and your mind is open, let's float into the quiet together. There is a kind of silence that isn't empty, a silence that holds its breath, that listens. This is not the silence of a quiet room or a still forest. It's the silence before even sound could begin. Tonight, you drift there into the space before space. The pause before the first light. You're not separate from it. You're of it. The universe, in all its complexity, didn't begin with fireworks. It began with possibility, resting, bliss, unshaped. There was no before this. No, really. Because time itself had not yet stretched awake. No ticking seconds. No aging stars. Imagine a sheet of calm. No ripples, no folds. Imagine a kind of waiting that doesn't feel impatient. It simply is. This is space-time before it bent, or broke, or bore galaxies. Not yet a road, not yet a fabric. Just the potential for paths to one day be made. Scientists sometimes call it a singularity, a place where all the rules blur, where space and time are crushed into pure potential. But maybe it's softer than that. Maybe it's not a point or a place, but a breath being held. A dream not yet dreamt. You rest here, in that hush, and something stirs. Not with noise, but with rhythm. The gentle push of expansion, like ink reading water blooming outward. Space begins to stretch, not into anything, but as everything. It's not that galaxies exploded outward into a waiting void. It's that space itself began to grow, like a balloon exhaling into itself. And time? Time flowed with it, woven in from the start. Not an arrow yet, just a whisper, a direction that only later became forward. In this early softness, there is no up or down. No here or there. There is only shape finding itself. The quiet learning to curve. The laws of physics, what we now call gravity, light, mass. They weren't written then. They were becoming. Even now, they shift at the edges of our knowing. But in the beginning, they were fluid, like paint not yet dry on the canvas of existence. And that canvas isn't laid on anything. It is everything. When physicists speak of space-time, they don't mean a backdrop, not a stage where the drama of the cosmos unfolds. They mean the stage and the script, the players and their shadows. all bound in a single, subtle weave. Spacetime is not a container. It is the very condition for anything to be. It curves, it ripples, it can even tear. But here, in this beginning, it simply holds. And so do you. You are held not just by blankets and quiet air, but by the gentle truth that you are inside something ancient. Not above it, not separate from it. You're a thread in the weave, your breath, your heartbeat, even your thoughts. They all stretch and stir within space-time's quiet fold. And it's never still. Not really. Even now, the fabric trembles softly, with waves from long ago. From stars that died, from galaxies that collided. They ripple through you like echoes in a sleeping sea. You may not feel them, but your atoms know. They dance, just slightly, to space-time's hidden pulse. And if you ever wonder what space feels like, remember this. It is not cold or distant. It is soft, flexible, attentive. It bends near mass. It listens to motion. It holds you without arms. So you float here, just for a while. An ash before stars. And the warmth before time. You're not lost. You are exactly where the universe began. In the stillness that birthed the first moment. And somewhere, gently, a curve begins to form. A soft suggestion of shape, not from outside, but from within space-time itself. It's time to ask, what happens when light tries to travel through something that can bend? What happens when the straightest path in the universe turns out not to be straight at all? And so, you drift now toward a quiet, glowing question. What is the geometry of light's path? You open your eyes not to a room or a horizon, but to something that stretches in all directions. There's no wall to mark the end, no ceiling where the stars stop. Only more and more space, more stillness, unfolding sky. But where does it go? And where does it stop? Tonight, you let that question carry you, like a slow tide, not toward an answer exactly, but toward an understanding. The universe has no edge, and that is not just poetic. It is physical. You live inside something that doesn't end in a line. It loops, curls, and stretches beyond your seeing. It expands, yes, but not like water into a bucket. It expands as itself. Imagine the surface of a balloon. Now imagine you're a tiny creature on that surface, a single speck on the skin of a growing sphere. You walk in one direction, and you never fall off. Never reach a ledge. You circle the curve again and again. Not because there's a fence, but because the space itself is round. Now take that idea and add one more dimension. You're no longer on the skin. You're inside the balloon. And the balloon isn't in anything else. It is the everything. That's your universe. No border. No edge to lean on. Only a geometry that repeats gently, endlessly. Not flat, but curved, in a way your eyes don't quite see. Cosmologists call it finite, but unbounded. It's not infinite in a way numbers go on forever. It's more like a circle. You can travel and travel, but you'll never fall out. And even though the universe grows, it doesn't grow into something. There is no outside, no surrounding void. Just the fabric of space itself, stretching not pushed from outside, but unfolding from within. You are part of that unfolding, not riding on top of it. Even the light from distant galaxies feels it. As space expands, the light stretches too. Its color shifts redder, softer, like a sigh across time. Astronomers call this redshift. It's not because the galaxies are running from you. It's because space itself is expanding between you and them. The balloon stretches, and every thread goes farther from every other. Still, this growing doesn't mean the center is elsewhere. There is no center, no special place. Everywhere is the middle, because there is no edge to compare it to. Even where you lie now, soft, still, listening is just as central as any star or supercluster. This idea can feel dizzying. You may wonder where to stand, how to be small and grounded in something with no bounds. But maybe the comfort is in this. You're wrapped in a universe that doesn't end in cliffs or corners. It folds around you like the surface of a planet, like the curve of a sleeping keta, soft, continuous whole. And the math of it, the quiet, beautiful geometry, matches what the night sky shows. The light from galaxies, the glow left from the Big Bang, it all whispers the same truth. The universe curves gently, perhaps not tightly, like a ball, perhaps not even at all in some places, but enough to say this is not a flat stage. This is a living shape. You could walk in one direction forever, and maybe, just maybe, return to where you began. Not by turning, but by continuing. It is the cosmic version of a lullaby that loops, never ending, never repeating exactly, but always flowing. Even time, in this universe without edges, follows no hard line. It ripples. It dances with space. Together they form a single thing, spacetime, a woven cloth without seams, a map without a margin. You exist here. You rest here. Not on a platform, but inside the shape of everything. And this shape remembers you. It holds your movements. It curves gently under your weight, like a mattress remembering sleep. So when you look up or inward and ask, where does it all go? The answer may be softer than you expect. It doesn't go outward. It folds. It becomes. It breathes. And what does it mean to be held in such a place? To live in a universe with no walls to stop you and no edge to fear? It means your steps echo in something infinite. It means even stillness is a kind of movement. And it means you are never separate from the shape of the cosmos. But now you wonder, if space can curve, if the universe itself can bend without breaking, what happens to the things that move through it? What happens to something like light? And so, softly, you begin to drift toward another question. Not about space itself, but about the path that cuts through it, the geometry of light's path. Light is often described as fast, but it is more than that. It is faithful. It moves at the same speed everywhere, always. Not because it is stubborn, but because the universe asks it to. You may imagine light travels in straight lines, like a ruler laid across the sky. And for a long time, we believed this too. But tonight, you learn that straight means something else entirely. When the stage itself can curve, you lie back and imagine light leaving a distant star. It begins this journey with confidence, but the space it travels through is not flat. It is shaped by mass it passes. Stars, planets, you. And so, the light curves. Not because it is pulled, but because the path itself ends. This is the quiet revelation of gravity. It is not a force that yanks or tugs. It is the shape of space, changing the path that light takes. Imagine a marble on a stretched bedsheet. If the sheet is flat, the marble rolls straight. But drop a heavy ball into the sheet, and now there's a dip. The marble rolls past not in a straight line, but in a curve that follows the new shape. This is how gravity works. Not as a hand that reaches out, but as a soft distortion in the fabric of space-time. Mass tells space how to curve, and curved space tells light how to move. This is why starlight bends around the sun. Why black holes catch it, wrapping it into spirals. Why entire galaxies can act like lenses, magnifying and stretching light from far beyond. It's called gravitational lensing, and it lets us see the invisible. When a massive object lies between you and something farther away, it bends the light like a glass lens, revealing galaxies too faint to reach you otherwise. The universe draws pictures with gravity, and you, lying still, eyes closed, are part of this vast artwork. Light passes through your world, bent gently by the shape of Earth, by the curve of your own body. But here's something even stranger. When space curves, time curves too. Space-time does not split. It is one thread twisting, folding, guiding. So, as light curves around a planet, its journey through time bends as well. To follow the geometry of light is to follow the shape of time. Even though light moves at the same speed always, it does not always take the same amount of time to reach you. Because time itself flows differently in curved places. You felt this, though maybe not in stars. You felt it in moments. How sometimes a minute stretches wide, and sometimes an hour slips by unnoticed. The cosmos does the same, but with precision only physics can see. A beam of light might curve just slightly on its way through the gravitational field of Earth. It might delay by a fraction of a second. But in that fraction, a truth is written. The world is not flat. It has form, and light, obedient and unwavering, reveals that form with every step. You may ask, what does it mean for a path to be straight in a curved world? Physicists call it a geodesic, not the shortest path across space, but the path that space itself defines as natural, like walking along the curve of a hill instead of cutting through the air above it. Light follows the geodesics of space-time. It does not resist. It flows. Even when space-time is twisted around a spinning planet or a rotating black hole, light follows the twist. It spirals, loops, or stalls, caught not by force, but by shape. This is not metaphor. It is real. Satellites orbiting Earth must account for the way space-time curves, or their clocks drift. GPS works because we understand how gravity bends both space and time. You carry this understanding with you, even as you rest. Every message sent, every image from a distant telescope. They all depend on the geometry of light's path. But there's something poetic in this. Light always moves forward, yet its path is shaped by what it passes. It is changed gently by what it encounters. In a way, you are like that too. You move through time and memory, and your course is shaped by the presence of others. Their gravity bends you not to control, but to remind you that we never move in isolation. Even alone, you travel through a curved world, and the light that touches your eyes has been shaped by ages, by the weight of distant suns, by the quiet swell of expanding space. There is one more thought to drift with tonight. As light bends, it shows us the invisible. A star behind a galaxy, a planet in front of a black hole. Curved light reveals hidden truths. And so you wonder, if light can curve through space, can time curve too? Can the seconds bend, stretch, fold inward like space does? You begin to feel the weight of time pulling on the edges of your mind. Softly, like gravity in the bones. But as your thoughts settle deeper, you drift toward another gentle mystery, the gravity of a thought. There is something tender in the idea that nothing goes unnoticed by the universe, that even a whisper, a passing thought, might press gently on the shape of space. You are made of matter, and where there is matter, there is gravity. You do not float away. The ground does not forget you. Not because you are held down by force, but because space curves beneath your feet. This curve is subtle, quiet, like the memory of a dream you can't quite place. But it's always there, shaping every step, guiding the fall of leaves, pulling oceans toward the moon. Gravity is not a command. It's an invitation to move together, to gather, to touch without touching. Even in deep space, where galaxies spin and stars collide, gravity hums beneath it all. Constant, invisible, relentless in its softness. And here's something beautiful. You have gravity too. Your body, resting now under blankets or sky curves space ever so slightly. Not enough to bend light like a star, but enough for the universe to notice. In this way, you leave a trace, a presence that space-time remembers. Even your thoughts, those flickers of electric motion in your brain, they come from particles, from mass, from movement. And movement, however small, sings to gravity. Physicists don't yet have a full picture of how gravity works with thought, or how consciousness fits into curved space. But they agree on this. Everything that exists, everything that moves, or pulses, or breathes, participates in shaping the cosmos. You're not apart from the laws of physics. You're a note in their melody, and gravity, that soft song of mass and curve, responds to you. Imagine this. A heavy planet warps space like a deep bowl. A lighter moon nearby rolls toward it, not because it's pushed, but because the path beneath it leans inward. Now imagine thoughts not as weightless things, but as ripples in a brain made of matter. A brain that sits inside a body, which sits inside space-time. And as your thoughts move, so do particles. So does mass. So does space. The gravity of a thought may be small, but it is not zero. Nothing in this universe is ever truly still. And stillness, even when it seems quiet, still curves the space it rests in. When you lie down at night, you may feel small. You may feel like a passenger in a vast, uncaring cosmos. But the truth is quieter than that. You're not just in the universe. You shape it. Gravity teaches this, that presence matters. That to simply exist is to influence everything else. Even now, as you listen and drift, your mass presses slightly on the earth. The earth answers, curving upward to meet you. You're not pulled down, you're followed. And gravity doesn't ask questions, doesn't sort by importance. It listens to every atom, every bit of mass, every flutter of motion, and responds accordingly. The gravity of mountains, of oceans, of stars. They're louder, yes, but never more meaningful. Your body curves space. So does a cup of tea. So does a memory. So does a pause. And what is thought, if not a movement inside matter? A stirring within the folded fabric of your brain. The same rules apply. The universe listens, always. So when you think of someone, when you imagine a distant place, when you remember something beautiful, somewhere into the great gentle field of space-time, there is a response, a ripple, a realignment. Tiny, but real. Your gravity is not symbolic. It is written into the laws of nature. You are part of the equation. And gravity, in its quiet way, makes sure nothing goes unacknowledged. That's why two objects, no matter how far apart, are always connected by gravity. The force never truly drops to zero. It only fades, softens, but never ends. And perhaps that is true of memory, of presence, of love. You leave something behind, just by being, just by thinking, just by letting your thoughts move through your quiet mind here in the slow rhythm of night. Your gravity is not something you control. It is something you are, something you carry, like your breath, like your name. And so, as you lie here, not doing much at all, remember, you're shaping the shape of the world. And now, as gravity holds you gently in place, you begin to sense another force, a stranger one. It moves time like taffy, slowing it, stretching it, softening its rhythm as it dances near mass. You wonder, can time itself curve the way space does? You follow that question into the gentle unfolding of the next thought, tugged by the tides of time. Time has always seemed like a river, something that flows in one direction. Steady, inevitable, carrying you forward with every breath. But what if it isn't? What if time isn't flowing at all, but bending, curving like space, tugged and twisted by gravity's gentle hands? Tonight, you lie still, but the time within you moves. And depending on where you rest, how far above the ground you are, how fast you travel, your experience of time changes. It's not just a feeling. It's not a trick of perception. It's physics real and measured. Time, it turns out, is not universal. There's no great clock in the sky, no master pulse ticking identically for everyone. Your heartbeat might feel steady, but your seconds are your own. Clocks on satellites, circling high above Earth, tick differently than clocks on the ground. And if you were to fly near a black hole, you'd find time itself slowing down, stretching into something syrupy and strange. This isn't fantasy. It's called time dilation, and it's as real as the ticking in your wristwatch. Time dilation happens in two ways. The first comes from motion. You move faster, much faster, and time begins to slow. Not for you, but for others watching you. It's not something you'd notice right away. There's no feeling of slowness. But the math shows it. The particles prove it. Time bends when speed rises. And the second kind, it happens in gravity. The closer you are to a massive object, the slower time moves for you. Stand at the base of a mountain, and time flows just slightly slower than for someone standing at the top. Just by being lower, closer to Earth's center, you fall deeper into its gravitational well. Time stretches to climb out. And so, you and a bird above you experience slightly different universes. Not because your world looks different, but because your moments unfold at different rhythms. This isn't metaphor. It's been measured with atomic clocks, so precise they wouldn't lose a second in millions of years. Clocks flown in airplanes. Clocks lifted by mere centimeters. Clocks proving that time is a shape, not a straight line. And your body knows this too. Your cells divide in rhythm. Your heart beats to a beat here. And all of it is influenced softly by your position in the curve of space-time. You are, quite literally, tugged by the tides of time. Think of the moon and its pull on the oceans, the rise and fall of waves. Now imagine time doing the same. Invisible tides, not of water, but of seconds, of aging, of memory, stand near a massive star, and your minutes stretch out. Fly into deep space, and time speeds up again. The deeper the gravity, the slower the clock. This is why astronauts, those quiet voyagers above Earth, age ever so slightly slower than those who stay behind. They return not only changed, but younger. By mere fractions, but younger all the same. You begin to see time not as a stream, but as a fabric, just like space woven together. One cannot exist without the other. It's called space-time for a reason. It's not space and time. It is one thing. A four-dimensional field that curves when mass is present, that stretches when energy pulses. And you live entirely within it. Every breath, every blink, every dream, all happens inside this shape. You're not simply moving through time. You're part of how time is defined. Your movement, your mass, your stillness, they all write soft instructions in a language of space-time. And so, when you remember something, when you imagine the future, you're not outside of physics. You're inside a field that remembers and anticipates. Past, the now, the next, all stitched into the same cloth. There are theories that say time itself may be an illusion. That what you feel as a flowing moment is simply a perception of position along a timeless whole. But even if that's true, you feel the curve. You feel the difference between yesterday and tomorrow. You feel the pull of heavy things on your minutes. And now, lying here, you can imagine it. A world where time is not measured by clocks, but by closeness, by motion, by gravity. I begin to sense that time is not separate from space. It rides along its curves. It slows near stars. It speeds in a void. And when you fall asleep, your body shifts rhythm. Your perception bends. You step into a different kind of time. Softer. Slower. Perhaps your dreams, like light near a black hole, stretch into longer seconds. Perhaps the tides of time cradle you more gently here. You're not just drifting off. You're entering another edge of the space-time fabric. Still held. Still moving. Still curved. And as you begin to float towards sleep, you wonder something else. If time can bend and space can stretch, then what about the shape of nothing? Close your eyes for a moment. Now picture nothing. Not darkness. Not silence. Not an empty room or a quiet night. Try to picture a place that is truly empty. Not made of anything. Not inside. Not surrounded by anything. It slips through your fingers, doesn't it? Because even nothing feels like something when you try to hold it. But tonight, you explore it anyway. The shape of what isn't. The presence of absence. The fabric of space itself. You've been told space is empty. A vast vacuum between stars. A black canvas on which galaxies are painted. But that's not quite right. Space isn't just what's left when all the stuff is taken away. Space is something. It can bend, it can ripple, it can stretch, and if it can change, then it must be. The vacuum of space is not a true nothing. It's a sea of possibility, a restless field. Even in the quietest corners of the cosmos, particles flicker in and out of being. Energy dances unseen. And space holds this dance. It is not a container, but a partner. Imagine stretching a rubber sheet. You pull it outward, and though it was once flat, now it curves, bows, holds tension in its threads. Now take away the rubber, take away the texture, and still the tension remains. Because space isn't made of things. It's made of relationships, distances, angles, curves. In physics, this is sometimes called the metrica, way to measure how far apart 2 points are. Not by rulers, but by how space itself wants to behave. It's why light curves, why orbits spiral, why falling feels like flying through bent space, and why nothing always has a shape. If you could stand in true vacuum, no stars, no atoms, no heat, no light, you would still not be alone. You would be wrapped in spacetime, a silent presence, invisible but real. Even the vacuum has energy. It's called 0-point energy, and it's a buzz that never goes away. Not noise, but a hum beneath the lowest possible note. Particles borrow from it. Virtual particles, tiny ghosts of matter and antimatter, blink into existence and disappear again. And this, too, is shape, a fluctuation, a rhythm in the nothing. What you think of as nothing is more like the surface of a still pond, waiting, listening, sensitive to even the gentlest breath. And if you were to drop a stone, a star, a planet, a galaxy, into that pond, the ripples would spread outward, changing the shape of everything. So you see, this is not just the stage. It's part of the play. When the cosmos was, space was born with it. And ever since, it's been shifting, curving, growing. Even now, it's expanding not into a larger room, but as the room itself. Every moment, new space is made, not from stuff, but from stretch. And the more it stretches, the more that nothing begins to feel like something soft, something responsive. Perhaps that's why you can't picture emptiness, because emptiness isn't truly empty. It always holds shape. And maybe that's what allows things to exist at all. The fact that the background can bend, that space can cradle energy, guide motion, and whisper to time. Even in the silence between heartbeats, space is present. Even in the dark between stars, it holds form. You live in it, move through it, but never escape it. Even when you sleep, the shape of space sleeps with you. And here's a gentle thought to keep you company. If nothing can have shape, then what else do we overlook when we imagine it's empty? A pause in a song, a blank page, the space between breaths. They, too, have form. They create room. They make meaning. Just like space-time, they're not absence, but potential. You float, now not lost, but gently held in something that doesn't need walls. The shape of nothing curves around you, not to contain, but to remind you. This universe began not with stuff, but with structure. And before anything could be born, space had to stretch. Time had to soften. Vacuum had to tremble with the first possibility of presence. You are part of that legacy, a structure within a structure, held in the gentle curve of what once was nothing. And just as you're starting to understand how empty space is never truly empty, a new ripple appears in the distance. A wave, but not of sound or light. Something deeper, something older. You lean into it softly, drawn by the gentle pull, and begin to feel the vibrations of the cosmos itself. Next, you will hear them. Ripples in the infinite. You're lying still now, wrapped in quiet. The world is hushed. And yet, beneath that silence, something moves. Not the rustle of leaves, not the hum of distant traffic. Something deeper. Something that doesn't need air, or matter, or even sound. A ripple passes through you. Gentle. Ancient. It stretches space, then releases. And again. You don't feel it, not directly. But it happens. Even now. Even here. This is a universe remembering itself. Gravitational waves. Not light, not sound, but a trembling in space-time itself, as if the very fabric of the cosmos had been plucked like a string. These ripples don't travel through space. They travel as space. When they pass by, they stretch the distance between things, then compress it back and forth, softly, rhythmically. But where do they come from? You drift now, half dreaming, and you see them. Two massive stars, locked in a dance. They spiral closer and closer, the gravity pulling tighter with every turn. Faster, fiercer. Until finally they touch. They collapse. In that final moment, energy bursts out, not as fire, not as light, but as shape. A ripple forms in space-time, as if someone had dropped a pebble into the stillest pond imaginable. And that ripple, it travels for billions of years, unaffected by dust, untouched by darkness. It keeps going, unfazed, unstoppable, until it reaches Earth. It doesn't shout. It doesn't flash. It merely shifts the distance between 2 points by less than the width of an atom. But that is enough. Because now, we are listening. In 2015, scientists heard the universe hum for the first time. Gravitational waves, predicted by Einstein 100 years before, finally felt. Finally seen not through eyes, but through instruments as delicate as the ripples themselves. They were built to notice the smallest change in length, to measure the warping of space as a wave passed by. And when it did, we knew. We'd touched something that had never been touched before. We'd felt the pulse of colliding black holes. Can you imagine? 2 black holes, invisible, unstoppable, locked in orbit far away in the darkness, spiraling until they became one. And in that merging, they sent a message across time. That message is still moving, still rippling, and so many others follow. From neutron stars, from collapsing giants. Each one sings its own song, not in notes, but in curves. It is a kind of cosmic music, a vibration that carries memory not of things, but of events. Because that's what gravitational waves truly are, moments made physical. The echoes of something happening, too far, too hidden, for light to show. And the universe is filled with them. The constant quiet of motion and mass. You've lived your whole life inside this trembling. You've been wrapped in the aftershocks of ancient collisions. They pass through you, without pain, without trace. But they are real. And now that we can hear them, the universe feels deeper, or layered. As if beneath the stars, there's another world, one made not of light, but of pulse. Think of it this way. If light shows us what is, gravitational waves show us what happened. They reach us not as photographs, but as footprints, moments etched into the structure of space. And you rest in this structure. You are not separate from the waves. You are curved by them, as the earth is curved, as time is curved, as thought itself may be curved. Gravitational waves do not carry color, or heat, or sound. They carry movement, a reminder that even the most massive objects are not still. Even black holes, which trap everything else, still create motion, still leave ripples as they vanish into silence. And as these ripples pass through the earth, they pass through you softly, briefly, like a sigh. They're not dangerous. They're not loud. They're simply the universe reminding itself that something once happened, far, far away. In this moment, you understand you are inside a living fabric. You don't just watch the cosmos. You participate in its rhythm, its trembling, its gravity. And maybe if the stars remember each other this way, through ripples, then so do we. Maybe everything we do, everything we are, leaves a trace, not just in memory, but in the subtle curvature of the world, in the way we bend space with presence, with gravity, with thought. You breathe now, slow and steady, and somewhere a ripple passes. Born before you were, still traveling, still becoming. And as you listen for the next one, you wonder, how do we measure time in a world that bends? What kind of clock can count the seconds when space-time itself curves with every step? You open your mind to a new question, gentle and strange. The clock inside the curve. There is a clock inside you. You may not hear it ticking, but it pulses all the same in the rise of your chest, in the rhythm of your thoughts, in the slow drift of sleep. Time is not something you watch. It is something you are. But now, imagine a journey. You walk a hill, not a steep one, just gently sloped. Each step takes you higher, and with each step, something invisible changes. Your feet feel the same ground. Your lungs take the same breath. But your clock ticks differently. Not broken, not wrong, just different. This is not imagination. This is real. In the curved world of space-time, time is not uniform. It depends on where you are, and how fast you're moving, and how deeply you sit in gravity's palm. Two clocks, one in a valley, one on a mountaintop, will tick at slightly different speeds. Even though they look identical, even though they were built to match. This strange truth was once only theory. Now it's measured, proven, even accounted for in the machines that guide planes, map streets, run your phone. Because if we ignored the curves of time, your GPS would be wrong. Your signals would drift. Your sense of now would slip quietly apart. So we've learned to listen, to respect that time isn't flat. It flows differently, depending on the shape of the world around it. And shape is everywhere. Even here, in your quiet room, the ground beneath you curves space, just enough to change the rhythm of your seconds. It's a soft curvature, like a whisper bent around a corner. But it matters. You're not on the outside of time. You're inside it, curving with it, carrying your own clock through a world of uneven flow. This is the heart of relativity, that there is no master clock, no single now that rules all others. Instead, there are many clocks, many paths, each one shaped by how it moves and where it bends. Time dilates, they say. It stretches, not like rubber, but like memory. Longer in some places, shorter in others. Think of an astronaut orbiting Earth. Their clock ticks just a little slower than yours down here. Not because it's faulty, but because speed and gravity reshape time. The difference is tiny, but over long stretches, over journeys to distant stars, it becomes profound. Travel fast enough, and you could leap forward in time, not because you pushed time ahead, but because you lived more slowly while the universe carried on. There are no shortcuts, just different curves. You see, space-time isn't a map. It's a landscape, and your clock is a traveler along that landscape, adjusting, shifting, responding to every hill and valley and the gravity beneath your feet. It's not just machines that feel this. You do too. Your biology, your dreams, your memory of how long something takes. They all trace the curve. And in dreams, time feels stranger still. A lifetime can unfold in the space between two heartbeats, or a single moment can stretch like the golden hour before dusk. Perhaps your brain, your mind, knows something about curved time that your waking self forgets. You're not wrong when you feel time stretch. You're simply sensing a shape that your body understands better than words do. And what then is a clock? Not just a device, not just numbers. A clock is anything that marks change. A dripping faucet, a spinning planet, a sleeping heart, all clocks, all rhythm makers. Even light has its own clock. It moves always at the same speed. But its journey bends as distance warps. And so the rhythm must be understood within that bend. This is why time is measured in path show, far light travels, how space curves. To measure time, you must know how the world curves beneath it. You're never standing still in time. You're always climbing a hill, descending a valley, crossing a field of slurred distortions. But the beauty is this. Even in the curved landscape, your inner clock keeps ticking. Not separate from the curve. Part of it. Responsive. Adaptable. And maybe this is why you sometimes feel that time speeds up or slows down. Not because the clock lies, but because your clock and the world's clock are not always walking together. And when they drift, you feel the tug, like gravity, gentler. The tug of a moment stretching out. The tug of a memory coming sooner than you thought. The clock inside the curve does not resist the world's shape. It moves with it, softly sinking with every new turn. You rest now, aware of your own ticking, the quiet beat of your breath, the long hush of the night around you. Time is moving, but not away from you. It's moving with you. And as you turn gently into deep rest, a sense of question floating near. Where did all this begin? Who first imagined a world where time and space could bend and blend? You feel yourself being pulled, not by gravity, but by curiosity towards the quiet mind who first saw time not as absolute, but as part of a curve. You drift softly into thought. And soon you'll arrive at a revolution, whispered in equations. Einstein's revolution. The world used to be solid. Clockwork. Time ticked the same for everyone. Space was a stage, unchanging, unmoved, a vast emptiness waiting for matter to perform upon it. This was the view for centuries. Newton's world. Clean, clear, absolute. Every second identical to the one before it. Every place a static coordinate on a cosmic grid. But one quiet mind, not loud or fast, not filled with thunder, changed everything. Einstein. Not with fire, not with noise, but with a gentle thought so radical it bent the spine of the universe. You're lying here, resting, but let your mind float back to 1905. A young clerk in a Swiss patent office sits by a window, watching trains move, imagining what it would be like to chase a beam of light. He closes his eyes, and time begins to soften. What he sees is this. If light always travels at the same speed, no matter how fast you move, then space and time must twist. To make that possible, they must give a little. Flax. He calls this special relativity, a theory built on two simple truths. The laws of physics are the same for all observers, and the speed of light is constant. From those a new world unfolds. Time dilates, lengths contract. The faster you move, the more time and space adjust around you. It's not illusion, it's structure. You begin to see what he said, that space and time are not separate ingredients. They are one recipe, space-time, one fabric, one field. If you bend one, the other bends too. But that was only the beginning. Years later, Einstein deepens the idea. He stops thinking only about speed. Now he considers gravity. And here, in his theory of general relativity, the universe opens wider. Gravity is no longer a force. It's a result, a shape. Mass doesn't pull things. It tells space how to curve, and curved space tells matter how to move. A planet doesn't orbit a star because it's tugged like a ball on a string. It moves because space-time curves around the star. And the planet simply follows the easiest path through that curve. You see it now, like silk draped around a heavy marble. The cloth dips, and anything nearby rolls inward. Not because it wants to, but because the fabric tells it to. This quiet revolution rewrites everything from the falling of apples to the bending of starlight. Einstein predicts that light, though massless, will bend when passing near a star. Not because the star pulls on it, but because space itself is curved. And in 1919, during a total solar eclipse, scientists watched starlight bend around the darkened sun. Einstein was right. The sky had changed. For the first time, we see that the universe is not rigid. It is fluid, responsive, a geometry that lives and breathes, and gravity, that ancient, mysterious presence, becomes something new. Not a tether, not a force, but a message. a whisper that says, "This is how space bends. When I am here, you carry mass. So you bend space. So does the Earth. So does your heartbeat." Einstein's ideas unfold like quiet music. Beautiful, precise, and surprisingly intuitive once you feel their rhythm. Nothing moves through space-time without leaving a trace. A gentle tug, a ripple, an imprint. The equations he wrote became more than formulas. They became the grammar of the cosmos itself. He showed us that time can stretch, that simultaneity is relative, that space can expand, that the universe might not be eternal or still, but growing. Even now, we use Einstein's revolution to guide spacecraft, to listen for gravitational waves, to understand the curves between galaxies. You lie here, wrapped in your own quiet gravity, and realize this revolution didn't end. It continues in telescopes, in equations, in your very breath. Every moment you exist, you are following geodesics, the paths carved by spacetime's shape. You are falling forward through curved time, and you begin to wonder. If spacetime curves so gently, then how does it hold such vast things together? How does it cradle a galaxy, spinning and trembling, without coming apart? You reach for that next mystery softly now, as your thoughts begin to float. What anchors a galaxy? You drift through a slow spiral, not falling, not flying, just turning endlessly in the arms of something unseen. That's what galaxies do. They spin. They're grand, glowing worlds of stars, billions and billions of them. Each star dancing in a cosmic swirl that has lasted for billions of years. But there's a question. A quiet, persistent one. Why don't they fall apart? You close your eyes now and imagine one. A galaxy seen from far above. Arms of light curling outward, graceful as wind-blown petals. Every star in that spiral moves in its own orbit, circling the center, not randomly, but with astonishing rhythm. Now think of a spinning disk, a record player, or a whirlpool. The outer edge should move slower. The farther out you go, the weaker the pull should be. But galaxies don't follow that rule. Their outer stars move too fast, faster than they should. So fast, in fact, that by all visible measures, they should fling themselves off into the dark. And yet, they don't. They stay bound, spinning steadily. So what anchors them? What holds those whirling arms in place? For a long time, we couldn't see it, but we could feel it. In the way galaxies moved, in the way they bent the light behind them. There was something there, something with mass, something invisible. Dark matter. Not dark because it's evil or strange, but because it does not shine. It does not reflect or emit light. It simply exists, silently. It doesn't collide with atoms. It doesn't clump into stars. But it wraps around galaxies like a vast, unseen halo. It adds mass without form. And that mass shapes space. Halo. No resistance, no edge, just the presence of gravity without the presence of light. Dark matter makes up most of the mass in a galaxy. It creates the deep gravitational wells that hold the spinning stars in orbit. It doesn't glow. It doesn't gather. It simply curves space-time softly, everywhere. It's like scaffolding made of silence. the skeleton of the cosmos. You can't feel it with your skin, but your atoms orbit inside its field. So do planets and solar systems and the stars you wish on. Without it, galaxies would unravel. The arms would loosen, and the stars would drift like ash in the wind. But they don't. They stay, turning slowly like lullabies of gravity. And dark matter is not the only hand at work. There's the shape of spacetime itself, that great invisible fabric you've come to know. It curves around every mass. It curves because of every mass, and in those curves, galaxies find their paths. The spiral arms of a galaxy are not fixed objects. They're patterns, waves, like the ripples in a pond when you toss in a stone. Stars move through those arms, like dancers moving through a crowd. They enter, they linger, they leave. But the pattern remains held by gravity, sustained by motion. It's a kind of galactic traffic jam, where density increases, but not chaos. And at the center of many galaxies, including your own, there lies something else. Something unimaginably dense. A supermassive black hole. Millions, sometimes billions, of solar masses crushed into a region no larger than a single star. Dark. Silent. But holding the center. You might imagine it as an anchor, but it's not what keeps the galaxy spinning. Its mass is great, but it is still small compared to the galaxy's whole. Is a knot in the center of the spiral, a core of intensity, but not the sole reason the structure stays intact. That credit goes to gravity, to dark matter, to curved spacetime, and perhaps to harmony. Galaxies are not rigid. They are not machines. They are fluid, flexible, balanced in a dance between motion and mass. What anchors them is not a chain. It is the memory of balance, the shape of a field that knows how to hold. You rest in that shape. You live inside one of those arms, a faint thread of light within a spiral that takes 200 million years to make a single turn. And yet, you feel it. Some part of you recognizes the movement, the spin, the belonging. You're anchored to be gravity, by motion, by history. Even in your stillness, you're part of the swirl. And now, you begin to wonder. If light has a constant speed, unwavering, then what does that speed mean in a universe where everything moves, where everything curves? What does it mean for light to have a limit? And why must that limit be there at all? As your thoughts stretch toward that question, a new one gently unfolds. One that defines the rhythm of cause and effect, the beat of the cosmos itself, the speed limit of reality. There is a limit woven into the fabric of the universe, a quiet rule, constant and unswerving. Nothing outruns it, nothing breaks it. It is not a wall, but a rhythm, a speed so fundamental, everything else must bend to it. That speed is the speed of light, roughly 300,000 kilometers per s, fast beyond anything you've ever known, fast enough to circle Earth 7 times in a blink, but not infinite. And that is everything. Tonight, you lie still, where your thoughts begin to stretch, not in panic, not in effort, but in gentle curiosity. Why should there be a limit at all? Why must there be something that nothing, not light, not gravity, not thought can ever move faster than? To answer that, you return to the fabric, Spacetime. Not emptiness, but a woven field with rules that define what's possible. Imagine you drop a pebble in a pond. Ripples radiate outward, but never instantly. They take time to reach the shore. There's a rhythm to how far the ripple goes and how long it takes. That's how signals work in spacetime. Nothing can change instantly across the whole. Information must move, and the fastest it can ever move is at the speed of light. This is not just about light itself. This limit governs everything. Causality, the idea that one thing happens because of another, is defined by this speed. If you could exceed it, you could undo that order. Cause and effect would blur. You could arrive before you left, and the universe would unravel. So instead, the universe holds the line. It keeps the speed limit intact, even in its wildest corners. It means there are things you can never see now. Not because they don't exist, but because their light hasn't reached you yet. The universe is vast and growing faster each moment. Distant galaxies race away, their light stretched thin by expansion. Some light will never make it here, not in 1 billion years. Not ever. Because the space between is stretching faster than the light can cross it. You live in our horizon, a bubble of the observable, not limited by your tools, but by physics itself. But this isn't a prison. It's a structure, a cosmic architecture where things unfold in the proper order. And you are stitched into it. Your cells, your neurons, your voice, they all obey this rule. They all send signals at speeds no greater than this limit. Even electricity in your brain dances near the edge, but never breaks past. And light rides the very edge of time. It is not timeless, but time behaves strangely for it. From light's point of view, if it could have one, there is no passage of time between departure and arrival. It leaves one place and instantly exists in the next. Because light does not experience time. It exists on the razor's edge between moments. It defines distance. It defines time. The speed of light is not just a number. It is the conversion rate between space and time. You travel a meter in space, and you've moved a bit in time. You live through a second, and light has moved almost 300,000 kilometers. They're inseparable, bound by this speed. And if you approach that speed, time slows for you. Mass increases, distances contract, push harder, go faster. And these till length shrinks to zero. Energy becomes infinite. That's why you, with mass, can never reach it. Not because the universe is cruel, but because the laws are exact. To move at light speed, you would need infinite energy, and there is no such thing. But photons, particles of light, they are born with no mass, and so they glide forever at the limit. They are the messengers, the rule setters, the ones who carry time and space between all things. And you, slow and soft in comparison, are still part of that same dance. Every second that passes for you is measured in light's steps. Every star you see in the sky is light's memory of where it once was. When you look at the moon, you're seeing it as it was over a second ago. The sun, 8 minutes ago. The nearest star, over 4 years. Even your reflection in the mirror takes a fraction of a moment to return to your eyes. You never see the world as it is. only as it was, just moments before. Because light needs time to arrive. This delay, this slowness, creates something precious. Order. It tends to build cause and effect, to speak and listen, to move and respond. Without the speed limit, the universe would be chaos. Unwound, unreachable. So this tree, this ultimate speed, is not a limitation. It's a frame, a rhythm, the soft beat behind everything that becomes. And now, as your thoughts quiet and your body slows, you feel the stillness behind the speed. You do not need to rush to be a part of this rhythm. Even in rest, you're connected. Even in sleep, you are traveling through time, through space, held by the soft laws that cradle all motion. And as you drift deeper, you begin to ask, if space-time has speed and light has structure, what lies underneath? What is space made of? Is it a substance, a weave, a pattern? And so you move gently into the next quiet mystery. Can space be woven? You've been told space is smooth, continuous, flowing like an infinite ocean. No edges, no pieces, no gaps. But tonight, you begin to wonder, what if it's not? What if space, like cloth, is made of threads? Too small to see, too fine to feel. But there, all the same, a woven structure beneath everything. You float at the edge of thought now, where physics begins to blur into imagination, and imagination circles back into science. This is the realm of quantum gravity, where the rules of the very large planets, galaxies, black holery, to merge with the rules of the very small particles, forces, probabilities. It is not an easy conversation. The language breaks down. Einstein's smooth curves resist the jittery flickers of quantum mechanics. But somewhere in between, a bridge is forming. And that bridge begins with a question. Can space be woven? Some scientists say yes. Not with thread or string, but with loops. Tiny, quantized units of space-like grains, like quanta. This is the heart of loop quantum gravity, a theory that says space isn't infinitely divisible. You can't split it forever. Eventually, you reach a smallest unit, a thread, a node, a loop. Not particles of stuff, but particles of geometry. Imagine a vast, invisible net, woven from mathematical relationships. Each knot in the net represents a quantum of area or volume. No space between the spaces. No gaps, just connection, just structure. This fabric wouldn't feel rough to us. It would still seem smooth just as a table appears flat, even though it's made of atoms. But underneath, space might jitter, buzz, shift like static before a broadcast. Like foam at the edge of a wave. Physicists call it spacetime foam. A roiling sea of tiny fluctuations, so small they elude even our best tools. They ripple with probability. Nothing is certain at this scale, only possibility. You lie still now, but your mind is moving. You imagine yourself shrinking, smaller than atoms, smaller than quarks. You pass through protons as if they were cities of clouds. You fall into the vacuum and find it is not empty. It teems with loops, structures, tiny shapes flickering in and out, braiding themselves into the form of space. This may be the weave of the cosmos, a texture too fine to grasp, but essential to everything. And beyond the loops, another vision appears. String theory. It says the smallest ingredients are not points, but strings. vibrating strands of energy, each with its own tone, its own frequency. These strings stretch across more dimensions than you can see, perhaps 9 or 10 or 11, most curled up, hidden inside the folds of the world you know. But they're there if the theory is right, and their vibrations give rise to particles, forces, fields, even gravity. So space, in this view, is not just background. It is a product of how strings move and relate. Where there is no string, there is no space. Where strings interact, space grows. It is not a container. It is a consequence. You let this idea settle, like dust drifting in golden light. You don't need to understand the math. You feel the wonder, the simplicity behind the complexity. What if all of reality is music made visible? Vibration becoming matter, pattern becoming shape. In that case, space is not flat. It is humming, not silent, but full of sound too subtle to hear. And perhaps that hum is not random. Perhaps it is ordered, braided like river channels, woven like roots. This is the vision of spin networks, another idea born from loop quantum gravity. Imagine tiny units of spin, quantized bits of angular momentum, connecting like points on a lattice. Their interlocking relationships build space, not made of things, but of connections. You lie in your bed, but now you imagine the world beneath your pillow as made of countless links. A web with no strands, only relationships. This is not mystical. It is precise. It is math, rendered in rhythm. It is the idea that here and there aren't fixed points, but results of how things relate. What makes 2 points near each other? Not their placement, but their connection in the web. And when enough connections shift, a particle moves, a force is felt, space stretches, time flows. From this view, motion is not crossing distance. It's rearranging connections, like changing notes in a chord. So the question isn't, what is space made of? It becomes, how is space arranged? And now you see, space isn't passive. It isn't emptiness. It's a participant, a stage and a dancer, a fabric and a song. You feel grateful, not because you understand all the details, but because you sense the wonder. You're part of something that may be woven. You're resting in a world that might be handmade, from patterns too small to see. Even the silence around you might be made of loops. Even the pause between thoughts might be threaded with structure. And just as you feel held by that idea, a darker thread emerges. What happens when that fabric tears? Not frays, not folds, breaks. Can space unravel? Can it rupture? And what would lie beyond a tear and the thing that holds the universe? As your breath slows, you begin to drift toward the deepest fold in spacetime, where spacetime tears. There is a place in the universe where the map folds in on itself, where the grid of time and distance collapses into mystery. You've heard the name before, black hole. But it isn't a hole in the way a hole in paper might be. It's not an absence. It's not empty. It's something deeper. A place where space-time curves so sharply, so absolutely, that it ceases to behave the way you expect. You drift toward one now, not falling in, just observing. Quiet. Slow. Letting it come into focus, as gently as nightfall. A black hole begins as a star. one massive enough to collapse under its own weight. As it dies, its matter compresses inward, past the point of no return. Smaller, denser, tighter, until even light cannot escape. That's why it's black. Not because it lacks color, but because it keeps secrets. Whatever enters does not return. You reach the edge, the event horizon, the last visible border. It's not a wall. It doesn't push, pull. But it marks a threshold, beyond which the rules change. Inside, space falls inward at the speed of light, not objects within space. Space itself. It's as if the very fabric of reality is being poured into a funnel with no bottom. And what lies at the center? A singularity. That's the name we give it. Though it's more a question than an answer. A point where all the equations break. Where density becomes infinite. Where time stops. But let's slow down. You're still outside the horizon. Still in the realm where clocks work and distances make sense. But you can feel the tension. The stretch of space-time as it tries to hold its shape. The black hole doesn't destroy the fabric. It warps it. It drapes it inward, like a sheet drawn into a drain. From far away, this curve is graceful, predictable. Einstein's equations guide it well. But close in, near the edge, those equations tremble. They can't describe what happens at the singularity. That's where we say space-time tears. Not visibly, not like cloth, but in principle, in understanding. It's a place where the very concept of place loses meaning, where time might twist, or loop, or freeze, where distance shrinks to nothing, but gravity grows without limit. In this tear, we don't just lose sight of what's inside. We lose the ability to predict. And prediction is the heart of physics. It's how we understand the future. So when a black hole refuses prediction, it refuses understanding. It becomes unknown. Yet, some things escape. That, not light, but information. Perhaps that is the great debate. Can a black hole erase what falls into it? Can the universe lose memory? Or is the information somehow preserved? Scrambled across the event horizon, etched into the surface like code? This is the black hole information paradox. And it haunts physics. Because if information can truly be lost, then the fabric of reality is not as consistent as we believed. Hawking once said, black holes might slowly leak energy, a faint quantum glow, known as Hawking radiation. And if that's true, then black holes evaporate, vanish, leaving behind. If all disappears and no information escapes, and we're left with silence, an unfillable gap, a tear. And maybe the tear doesn't just mean we don't know. Maybe it means we can't know. That is what a singularity is at its core. Not just a dense point, but a limit of comprehension. A place the universe folds inward and asks you to let go. You lie here, miles from any black hole. Yet touched by this idea that space can bend so far it breaks, that time can stretch so thin it snaps, that there are places in reality where the story halts, where the page runs out, and the next begins in invisible ink. But still black holes are not the end of everything. They're part of the structure. They help galaxies form. They shape stars. They radiate. They spin. Some theories even suggest they're doorways, Not ends, but bridges. To where? We don't know. Perhaps other regions of space-time. Perhaps nothing at all. But the math whispers of possibilities, of white holes, of wormholes, of bouncing universes. And that's the gift of the tier. It invites imagination. It opens the door to new kinds of structure, to new shapes in a world we thought was smooth. You breathe now, slow and steady, still outside the edge, but aware that your universe has seams. It is stitched with rules. Beautiful, intricate rules. But in some places, the stitching is pulled too tight. And in those places, the fabric cannot hold. It slips into silence. Still, you wonder, if space-time can tear, can it also hide other paths, other folds, other rooms in the great house of being? You begin to sense a deeper kind of architecture, one with more dimensions than your senses reveal. As you drift further inward, you ask the next question. Dimensions you cannot see. You reach out, stretching softly in your mind. One hand forward, one hand sideways, and perhaps upward. Well, 3 dimensions. That's what your senses know. Forward and back, side to side, up and down. This is the space you live in, the space your body understands. But what if there's more? Not more space, but more directions. Not wider, but deeper, in a way you can't quite grasp. Tonight, you drift into those hidden folds, the extra dimensions, the unseen scaffolding of reality. In your waking life, you can't step into them. But in thought, in dream, in this quiet in-between, you can float through their possibility. Physics has long wondered, why only 3? Why do we feel so sure that space stops where it does? The answer might lie not in what we see, but in what we don't. It began with the equations, the ones that describe particles, forces, and the strange dance of quantum fields. These equations, beautiful and mysterious, start to make more sense when we add extra dimensions. Not dimensions like fantasy portals, but as mathematical directions folded up, curled tightly, so small you could never enter them. Only feel their effects. This is the heart of string theory, a bold idea that says everything in the universe is made of tiny vibrating strings. Not particles. Strings. And these strings need room to vibrate, not just in 3 directions, but in 6, 7, maybe in some versions, 10 dimensions, in others, 11. But why don't you see them? Because they are compact, curled into themselves like tight spirals woven into every point in space. Imagine a long, straight wire. From far away, it looks one-dimensional, just length. But up close, you see it cylindrical, with a tiny circular direction wrapped around it. Now imagine space like that. At every point, a looped path too small to travel, but still there. These tiny loops shape the way strings vibrate, and their vibration determines everything. Mass, charge, force. Each property of a particle emerges from how a string moves, in all dimensions, not just the ones you see. So in a very real sense, what you call reality is shaped by the invisible, by the folded, by the directions you can't touch. You lie back, still and open, and picture the universe not as empty, but as intricately folded. Not chaos, but origami. Space is not flat. It hides dimensions, like secret corridors in a familiar house. And these corridors aren't science fiction. They're the answer to deep, serious questions about gravity and quantum mechanics. Because if gravity is so much weaker than the other forces, electromagnetism, the strong and weak nuclear forces, then maybe it's because it spreads out into more dimensions, like sound leaking through thin walls. Perhaps gravity is not weaker, just diluted, leaking softly into the higher space we cannot see. And if that's true, then those extra dimensions aren't just mathematical curiosities. They are part of the way everything works. Some theories suggest entire worlds could exist in those dimensions, not above or beyond, but beside, so close and yet unreachable. Other Bernays' sheets of space, like ours, drifting through a higher dimensional bulk. Perhaps our universe is one surface, floating in a greater space. And sometimes these brains might collide. A big bang, not from nothing, but from contact. Creation through geometry. It's hard to imagine, because your senses were never built to see this. You evolved for trees and rivers, not curled manifolds and 11-dimensional math. But your mind can reach farther than your eyes. It can hold the abstract, the impossible seeming, with quiet grace. You don't need to understand every equation. You just need to wonder. What if, as you sit perfectly still, you're also extended into 6 invisible directions? What if your atoms vibrate in a shape you cannot know? But that shape determines who you are. You're not just here. You are curled into a richer geometry. And perhaps the universe remembers you that way, not only in length, width, and height, but in dimensions your heart can sense, only when it's quiet. This is not fantasy. This is physics at its edge, where theory stretches and the boundaries blur. Not because we've made mistakes, but because we've come so close to the fabric's threads that we begin to see its stitching. And just as you grow comfortable with the idea that space might be woven from more than you see, you begin to wonder about place itself. If space can bend and hide and twist through unseen directions, then how do you know where you really are? What does it mean to be here? Is location fixed, or is it also part of the curve? As your breath deepens, as your thoughts fold inward, you prepare to step into a new question. One that seems simple, but is anything but. A sea of coordinates. You open your eyes and say, I'm here. But what does here really mean? You might name it with an address, a country, a street. Or maybe you lift your phone, tap at a blue circle on a map, and a string of numbers appears. Latitude, longitude, elevation. That string is your location, your anchor in the world. But now, tonight, in a soft hush between questions, you begin to wonder. How does the universe know where you are? And what happens to here when space itself begins to bend? Coordinates are more than labels. They are promises, agreements we make with space to say, this is where that is. Every point, every planet, every pulse of light carries its own coordinates, its place in the sea of space-time. In simple places, space is flat. You can draw a straight line between 2 points and trust the distance. You can move north or east or up and know what it means. But the universe isn't flat. It curves, gently, subtly, in the presence of mass. Stars bend space. Planets curve it. Even your body has a whisper of gravity. So the coordinates you trust are always changing, just slightly. Just enough. Like trying to map a boat's position on an ocean that breathes. Physicists describe space with something called a coordinate system. It's not a grid you can see, but a mathematical map. A way to pin down locations in a world that won't stay still. But here's the twist. The coordinates themselves don't define reality. The curves do. The relationships, the geometry. You can pick different coordinates for the same patch of spacetime. You can stretch or squish them, twist them like clay. As long as you capture the curves, you haven't changed the truth. You've just changed the language. It's like describing a mountain with different maps. One topographic, one satellite, one drawn in pencil by a child. Each map tells the story a different way. But the mountain is still there. Your position, too, is not just numbers. It's how you are in relation to the universe around you. Path, time, motion. All part of the shape. Think of a GPS satellite. It tells you where you are by measuring time. Tiny clocks above the Earth, beaming pulses downward so your device can triangulate your place. But those clocks tick differently from ones on the ground because gravity curves time. The satellite is farther from Earth's mass, so time runs slightly faster. If we didn't account for that, our maps would drift. Our coordinates would lie. So even your phone accounts for Einstein, for relativity, for the bend in the sea of space. You may not feel it, but it is real. You are never quite where you were a moment ago. Even when you lie still, the world shifts beneath you. The Earth spins. It orbits the sun. The sun orbits the galaxy. The galaxy moves through the cosmos. And space itself, the very medium between things, is stretching. So where are you? You're here, yes. But here is part of a moving map. And the coordinates, those neat numbers, are snapshots of a tide. They work because we agree on how to read them. But deep beneath, they are built atop curves, and clocks, and bending beams of light. In general relativity, the map is not laid on top of spacetime. It is spacetime. The metric that elegant mathematical tool tells us how distances behave when space curves. It tells us what a straight line is in a world with no straightness. And those geodesic paths of light, paths of falling, become the compass points of this deeper navigation. Your breath moves with gravity. Your atoms follow geodesics. Your dreams drift through a curved sea. And the more precisely you try to know your place, the more uncertain you become. Not because of error, but because of nature. In quantum mechanics, location is probability, a blur, an openness. And even here, in the classical world, position is relation. To say where you are is to say where you are relative to something, to a star, to a clock, to a gravitational field. You're never somewhere all by yourself. You're always in context. So imagine now the space is not a grid, but a sea fluid, responsive. You float not on it, but in it. And your place is not fixed, but traced by motion, by history, by connection. Coordinates are useful, but they are not the ground. The ground is the geometry itself. The soft undulations that tell light where to bend. That cradle planets in their orbits. That cradle you in your moment of rest. You are not a point. You are part of the pattern. And this pattern reminds you gently. Where you are depends on how space curves beneath you. You're held in a net you cannot see. A sea with no edges. Just coordinates, floating on curved possibility. And so you wonder, as your body softens, as your breath slows, if straight lines can bend and space can curve, then perhaps straight isn't what we think it is at all. You begin to drift towards that question, drawn by its quiet contradiction, the illusion of straight lines. You imagine yourself walking in a straight line, forward, unwavering, step after step through a field or across a quiet floor. Eyes steady, shoulders still. And yet, in a world that curves, straightness is never quite what it seems. Even now, as you lie motionless, you live on a sphere. The earth beneath you is not flat. It bends, endlessly, gently. And when you walk across it, no matter how determined you are to go straight, you are, in truth, curving. Not in your body, but in your path. You're tracing part of a circle. Your straight is bent by the planet's roundness. And if you keep walking long enough, you'll end up right where you began. This is your first clue. Straightness is not absolute. It is local. A convenience. An illusion held close by our senses in a world that is far more complicated. In the language of physics, a straight line through curved space is called a geodesic. It is the path that an object follows when nothing pushes on it. No engines. Only the shape of space beneath it. Drop a ball from your hand, and it falls along a geodesic. Not pulled by force, but guided by the curve of Earth's gravity. The ball doesn't know about the ground. It's simply following the easiest path through a spacetime that dips beneath your feet. And that's the revelation. What you call a straight line is just the shortest distance, according to the geometry you're inside. Change the geometry, and the line bends. Not because it was twisted, but because the world turned beneath it. Imagine walking across a trampoline. If it's flat, you go forward with ease. But place a heavy stone in the center, and the fabric sags. Your steps begin to tilt inward, even though your feet point straight ahead. Space behaves the same way. Mass and energy warp it. The sun curves space around it. So do planets. So do you. And light always moving forward bends when it passes through those curves. That bending isn't a mistake. It's geometry. It's the truest path through a world that's not flat. You see this clearly in the cosmos. When starlight grazes a massive object, its path curves. Not because the light changes course, but because the straight line itself is curved. It's why you can see stars, even when they're hidden behind the sun. The light is bent just enough to reach your eyes around the edges. And so even the simplest direction a beam of light, moving with perfect discipline, is curved by space. What then is straight? In Euclidean geometry, the kind you learn in school, a straight line is the shortest path between 2 points. But that assumes a flat world, and the universe doesn't offer that. In curved geometry, Straightness depends on context. A geodesic on a sphere is not a line, but a circle, a great circle, like the equator. It looks curved on paper, but it is the straightest possible path on that surface. So you begin to realize there are no truly straight lines in the universe, only curves that feel straight because they follow the structure beneath them. Even time bends. Your experience of seconds flows through a spacetime that ripples and dips. You may believe you move steadily forward in time, but that motion is also a path through a curve. A clock on a mountain ticks differently than one at sea level. Not faster, not slower, just curved by position, shaped by presence. You're always curving, even when you feel still. Even your thoughts curve. They follow paths laid down by memory, by gravity, by emotion. So how do you navigate a world where straightness is an illusion? You trust the curvature. You move gently. You understand that no journey is rigid, and every path even, the one you take across your own life, is guided by bends. You cannot always see your muscles, your bones, your breath. They follow arcs, not edges. When you reach out in love, you do not send a beam. You create a ripple, a wave that curves through connection. This is what nature prefers. Smoothness. Transition. Not corners, but soft changes. Even rivers do not flow in lines. They meander because they follow the shape of the land. They teach you without words that the most natural path is rarely straight. And perhaps this too is a lesson from the universe. Don't resist the curve. Don't strive for the illusion of perfect lines. Allow your steps to wander gently. In this way, you live in harmony with space-time, because it is the curvature that holds the stars. It is the bending that keeps Earth in orbit. It is the illusion of straight lines that lets you feel stillness while you spin through space at thousands of kilometers an hour. And now, as your breath slows and your thoughts settle, you feel that motion, not in your body, but in your knowing. You're always moving, always tracing a curve through a curved world. Even in rest, your geodesic continues. And as you float along that smooth, unseen path, a new question arises. One you've perhaps whispered before. If lines can bend, and space can stretch, and time can curve with mass, could time, in some places, flow backward? You follow that thought into the next quiet unfolding. When time flows backward, time moves forward. That's what you've always known. One moment tumbles into the next, like beads on a string, or waves on a shore, never pausing, never returning. You age, but never unage. Memories grow behind you. Possibilities stretch ahead. And yet, in the soft hush of your mind tonight, as your breath slows and your thoughts begin to unspool, you wonder, what if time could turn around? What if, in some deeper truth, it already does? You float in this question, curious but calm, and begin to trace the quiet boundary between experience and law. Time feels like a one-way street. But the laws of physics, the deepest, most fundamental ones, they don't insist on direction. Take Newton's laws, or the equations of motion that govern the stars, the planets, the spin of electrons. They work just as well if you reverse the clock. If you filmed a comet's arc and played it backward, the path would still obey the rules. Still perfect. Still lawful. In those equations, there's no preferred direction. No sign that says this way only. Time's arrow, so obvious in your life, vanishes in the math. So where does that arrow come from? Why do you remember the past, but not the future? Why does a glass shatter on the floor, but never unshatter in your hand? The answer, as softly as it arrives, is entropy. Entropy is not chaos. It's not noise. It's a measure of how many ways a system can be arranged, how disordered it is, how spread out. A warm cup of tea left on the table is cold. The heat spreads into the room, not because heat forgets, but because disorder increases. The molecules dance into randomness. Energy disperses. That's entropy at work. It always increases. It defines the arrow of time in a very real way. You know the past because it was simpler, lower entropy, fewer possibilities. The future holds more outcomes, more complexity, more uncertainty. And that's why you don't unspill milk. Why smoke doesn't drift back into the match. But here's where the thought deepens. If the fundamental laws are reversible, then isn't entropy just a statistical truth? Not a law of nature, but a pattern of probability? You rest your head on that idea. Not heavy, just thoughtful. A deck of cards shuffled is unlikely to return to order. But not impossible. It could happen, just very, very rarely. So, as the universe began in a state of astonishing order, low entropy, then the rise of disorder gives us the arrow of time. But what if that initial condition had been different? What if time, somewhere else, flows the other way? There are physicists who imagine such things. A mirror universe, born from the same Big Bang, but unfolding in reverse. Not backward to us, but forward to its own perspective. From their view, we are the ones running in reverse. Our entropy increasing as theirs decreases. Two arrows. Two directions. One equation. One universe. Or maybe the whole spacetime is a four-dimensional block. And there, all moments are laid out at once. No past, no future. Just is. And your experience of time is like a flashlight moving across a page, illuminating one line at a time. But the whole story already exists. If that's true, then time doesn't flow. It's not a river, it's a landscape, and your consciousness travels through it as if on a path. In this view, time's direction is a feature of your perception. Your biology, your memory. The past feels fixed because it's remembered. The future feels open because it isn't. But maybe they are equally real. You pause now, wondering what it would feel like to live backward, to wake with memories of tomorrow, to fall upward, to heal into illness, to grow into childhood, to speak only words you're about to forget. That sounds strange, but is it impossible? Not by the laws, only by the starting conditions, only by the sheer improbability of reversing all motion at once. Still, in quantum mechanics, there are even deeper questions. Some interpretations suggest that particles can influence what happens in the past, that cause and effect are not so neatly arranged. A particle doesn't choose a path until it's observed. And that choice can seem to echo backward. It's not time travel, but it is time confusion. And then there's CPT symmetry, a fundamental principle that says the universe behaves the same if you flip charge, mirror spatial directions, and reverse time. CPT, 3 reversals, and the laws remain intact. It's as if time reversal is baked into the structure of the cosmos, not preferred, but allowed. And now, as you drift deeper, you begin to ask, if time can flow backward, even in theory, what would that mean for your own story? Would regret fade in reverse? Would love unbloom? Would life gain clarity as it returned to its origin? Or would it all remain the same, only viewed from another side? You imagine a universe, exhaling its breath and slowly breathing it back in. Galaxies falling inward. Stars condensing. Atoms rewinding. A cosmic film, played forward, then backward, and perfectly symmetrical. And somewhere in the middle, perhaps a point of balance. A moment when time does not point in either direction. Where entropy pauses and the arrow flickers. You rest now, not needing to decide. You are part of the unfolding. Whether time flows forward or not at all. And as your thoughts soften, you feel the edges of vision blur. If time can bend and possibly reverse, then there must be places where light cannot reach. Edges not of matter, but of knowing. Places where time and space stop speaking to you. And so you drift toward the edge, toward the outermost ripple of the visible world cosmic horizons. You open your eyes to darkness. Not the darkness of night, but of distance. A darkness older than you, wider than your dreams. This is the darkness of space, but more than that, the darkness of limits. The universe is vast, yes, but it is not endless in a way you once thought. It has boundaries, not in space, but in visibility. Boundaries drawn not by walls, but by time. Tonight, you drift towards one of them. Not with rockets, not with telescopes, but with thought. It's wonder. With breath. These boundaries are called cosmic horizons, and they are not edges you can touch. They are edges of knowledge, of reach, of light. Imagine standing in a wide open field. Fog surrounds you. You can only see so far, no matter how much you strain. The universe is similar. But the fog is not clouds. It is time. It is the finite speed of light. You see stars, not as they are, but as they were. You peer into the past with every glance at the sky. A star 100 light years away shows you its 100-year-old face. A galaxy 1 billion light years away shines with a billion-year-old glow. There is a horizon beyond which the light has not yet arrived. Not because it is too faint, but because it has not had time. It's the beginning. Time is the moment light first began its journey. This boundary is called the observable universe, and it stretches about 46 billion light years in every direction from where you sit. Yes, the number is strange. You might wonder, how can that be? If the universe is only 13.8 billion years old, the answer lies in expansion. The universe has been growing since the Big Bang. Not like a balloon inflating into something, but like space itself, stretching everywhere, all at once. So the light from those distant places left long ago, but the space in between has expanded. The source is now further than its age suggests. You lie still and imagine it. A great sphere centered around you, filled with everything, whose light has had time to reach your eyes. That is your cosmic horizon. But it is not universal. If someone were on a distant galaxy, their observable universe would be different, overlapping with yours, but not identical. Every being on every world has their own horizon, a personal bubble of knowable existence. It's humbling and also beautiful, because it means your view of the cosmos is intimate, shaped by your location, your motion, your moment in time. But there is another horizon, deeper still, a cosmic event horizon, not just a limit to what you see, but a limit to what you will ever see. Because the universe isn't just expanding, it's accelerating, driven by something mysterious, dark energy. Space stretches faster and faster as time passes. Galaxies are being pulled away, not by motion through space, but by space itself, expanding between them. And some are receding faster than the speed of light. That might sound impossible, but it isn't. Nothing in space can move faster than light, but space itself can expand as fast as it pleases. It's not bound by the speed limit it carries. So there are galaxies, entire galaxies, whose light emitted today will never reach you. Not in 1 trillion years. Not ever. They're beyond the event horizon. And each second that passes, more and more galaxies cross that threshold. They vanish from future view, even though their light still lingers from ages past. It's like hearing an echo from a friend who's already gone. The voice is there, but their presence is not. You float now in this knowledge, and it feels both quiet and infinite. You're surrounded by the light of lost things, and even as you gaze into the sky, your horizon narrows. One day, the Andromeda Galaxy will merge with ours. But long after that, far future civilizations may see only a lonely island of stars. All other galaxies hidden beyond the curtain of acceleration. Their sky will be darker, their maps smaller. Unless they remember us, we'll find our messages written in photons. But here, now, you still have a full sky, a sky filled with billions of galaxies. Each one a swirl of stars, each one a beacon from another place, another past. You're lucky, not just to exist, but to exist now in the brief era where so much can still be seen. You're a witness to a cosmic window, a moment of openness in a universe that is slowly closing its view. And even more quietly, you realize the horizon is not just out there. It's also within. Your brain has limits. Your tools have limits. Even thought has its edge. No matter how far you peer, there will always be more beyond. Not because it is hidden, but because you are finite. And that's okay. To live within a horizon is to live with mystery. It means you can always wonder. You can always reach. You can always let the silence be filled with possibility. The horizon is not a wall. It is a doorway into humility, and perhaps a little bit of faith that what you cannot know still matters, still sings. You lie here, wrapped in space-time, and it cradles you like the smallest of stars. Your thoughts drift outward, toward the rim of visibility, and then gently inward again. Because as vast as the cosmos is, there are mysteries folded deep within you. Where is your center? What lies at the core of stars and planets and particles? What happens when you press deeper, not outward, but inward? And what secrets wait at the heart of all things? In the next breath, you begin your descent. Not into darkness, but into density. Not into space, but into gravity's most curious puzzle, the heart of a black hole. Imagine floating in space, gently. Your limbs loose, your thoughts even looser. No wind, no sound, just the infinite hush of distance. Ahead, there's a shadow. Not like darkness, but the absence of knowing a self. A black hole. Not an object, but a place where the rules change. You're not afraid. You're curious. You drift closer, drawn not by force, but by fascination. Black holes are not monsters. They're not holes in the usual sense. They're places where gravity becomes too much. Where the fabric of space-time pulls so sharply inward that not even light can escape. This boundary is called the event horizon, the surface of no return. Once crossed, all paths bend inward. Not even light can claw its way back. But from the outside, you wouldn't see drama. No explosion. No swirl. The black hole just sits there silent, perfect, opaque. It could be the size of a city and weigh more than our sun. Or it could be at the heart of a galaxy, weighing millions, even billions of suns. These supermassive black holes anchor galaxies. Our own Milky Way has one Sagittarius, an asterisk. You orbit it every moment of your life, quietly, faithfully. But tonight, you imagine falling in. You cross the event horizon without noticing. There is no bump, no flash, just a soft shift in what's possible. Outside, time ticks along steady, familiar. But for you, time begins to. Or rather, the way time seems to pass for others stretches beyond comprehension. To an outside observer, you never quite cross the horizon. You freeze there, your image suspended, redder and dimmer, until it vanishes. But from your own view, you move freely, deeper, downward. What lies at the center? Physicists call it the singularity, a point of infinite density, where the known laws of physics cease to make sense. It's not that the laws break. It's that they no longer apply. The numbers run wild. The math says, I cannot follow you here. In the singularity, space and time collapse into one another. There is no where. There is no when. Only a boundary of comprehension. You may think of it as a dot, a center. But it's not truly a place. It is the end of description, the edge of the known. So you ask yourself, does this singularity truly exist? Or is it simply a sign that our understanding is incomplete? Many scientists believe the singularity marks a limit, a place where general relativity and quantum mechanics must merge. Right now, they don't. Einstein's theory bends space and time, but quantum theory weaves uncertainty and probability. Black holes ask both to speak at once, and they stutter. Some dream of a quantum gravity theory that will smooth the singularity into something real. A dense core, a looped knot, a remnant of pure geometry. Others wonder if singularities are just illusions, like mirages appearing, only because we look from a certain angle with imperfect tools. And still others imagine that inside a black hole, a new universe may be not an end, but beginning. A bud forming beneath a shell. You let your thoughts wander there too, the possibility that black holes give birth to entire new spacetimes, hidden from view, but expanding within. In this vision, each black hole is a seed, each singularity a spark. Our universe may have emerged from such a place, a singularity, not in someone else's black hole, but in our own past. And so you spiral deeper, not into destruction, but into mystery. Because there are still puzzles here, resting like ancient fossils in the curve of the equations. One is information. When something falls into a black hole, what happens to the details? The patterns, the structure, the data? Does it vanish? Is it erased? That would violate the rules of quantum physics, which insist that information is never lost, only transformed. So the information paradox was born. Stephen Hawking famously argued that black holes emit radiation, now called Hawking radiation. Tiny quantum effects at the event horizon that slowly bleed the black hole's mass away. But if it evaporates, what happens to what fell in? Can the outgoing radiation somehow encode all the fallen data? Does the surface of the black hole store a kind of cosmic ledger, an imprint of everything it consumes? This idea that information may be stored on the horizon itself led to a radical proposal, the holographic principle. It suggests that everything happening inside could be described entirely by data on the surface. Just as a two-dimensional hologram can hold the illusion of 3 dimensions, so might the boundary of a black hole contain all that lies within it. And maybe, just maybe, this principle applies to the whole universe. You may be living inside a cosmic hologram, 3-dimensional world, projected from the distant boundary of the universe itself. It's a wild thought, a poetic one, but it emerges from deep math, from string theory, from gravity and information woven together. And here you are, resting in the weightless dark, wondering what lies beneath the horizon. The truth is, we don't know. Not yet. But black holes invite us to keep asking. They remind us that gravity is more than a force. It is a teacher. They whisper that endings may be beginnings, that time can pause, that space can fold. And you, curled on the edge of sleep, feel the singularity not as fear, but as invitation. You drift now in silence, not falling, not rising, just being. And in a universe that hides some truths to keep you searching. And as your breath slows, you wonder, if a black hole can hide the core of space-time, what else might be hidden beneath the curves of gravity? Could ripples from a distant merger reach you here? Could the universe tremble softly in waves that stretch everything space, time, even sleep itself? You listen, and you wait. Because up next comes a sound you cannot hear with ears alone. The song of gravitational waves. Close your eyes. Let silence settle like snow. Let your limbs loosen, and your chest rise and fall until you feel yourself become part of the background. Now listen, not with ears, but with stillness. You are listening for the faintest song the cosmos can offer. Gravitational waves, They do not ring like bells. They do not crack like thunder. They stretch and squeeze. They pass through you, through the earth, through your body, through all things, and leave only the tiniest echo behind. But that echo tells stories older than memory and louder than sound. Gravitational waves are pulse in spacetime itself, not in air or water, but in the fabric of the universe. The very geometry you live inside trembles when something colossal moves. Think of spacetime like a pond. Toss in a stone, and ripples spread outward. But here, the stones are stars. The ripples are reality, and the pond has no edge. Einstein first predicted these waves over a century ago. His equations said that when masses accelerate, especially enormous ones, they should radiate energy in the form of waves that travel at the speed of light. Yet, for decades, no one could find them. The ripples were too subtle, too shy, until the 21st century. That's when a pair of laser eyes, buried deep on Earth, finally saw one, felt one, measured the stretching of space by less than the width of a proton. The observatory was called Lagotha Laser Interferometer, Gravitational Wave Observatory. 2 long arms, each 4 kilometers in length, forming an L shape. Lasers bounced between mirrors in perfect balance until a gravitational wave passed through. One arm stretched, the other compressed. Just a whisper, just a breath. But in that tiny motion was the story of 2 black holes colliding over 1 billion years ago. 2 giants, each perhaps 30 times the mass of the sun, spiraled into one another, moving faster and faster until they merged in a flash of invisible force. No light, no fire, just the folding of space. That collision sent out a ripple, which traveled across the cosmos, expanding ever outward until it brushed gently against Earth. And we heard it at last. The signal lasted less than a second. It sounded, if turned into audio, like a chirp. A soft rising tone from deep bass to a sweet upper note than silence. That was the universe singing. That first detection, made in September of 2015, was a triumph. Not just of engineering, but of patience, of faith. It proved that space could move like music, that gravity could dance. Since then, we've heard more black holes merging, neutron stars colliding, even a cosmic duet that sent gamma rays racing ahead as the stars fused into one. You picture it now. 2 neutron stars, the densest things in existence. Each no larger than a city, but heavier than the sun. Locked in a death spiral, they orbit, pulling on one another, dragging space-time with them. Faster, closer, louder, then, final as impact, a spray of gold and platinum, a shock wave of light, a rippling in gravity that spans the universe. It's from these collisions that many heavy elements are born. The gold in your ring, the iodine in your body, the uranium buried deep in rock. They were forged in the crash of dead stars. So when you feel the tug of gravity, remember it is not just a force. It is a story, an echo, a song. But how do you catch such a song? The detectors, LIGO, Virgo, Kagraus, lasers, and mirrors, so precise. They can detect movements 1,000 times smaller than an atom. They must account for wind, for earthquakes, for trucks on nearby roads. Even quantum fluctuations in the mirror coatings are considered. because the signal is delicate. It does not knock. It barely taps. And yet, it carries the weight of colliding stars. You think about this, how something so large can feel so quiet. And it makes sense. You've known this before. The deepest emotions move quietly. The greatest truths often whisper. Gravitational waves reveal not only what happened, but when and where. They carry memory without form. And they also offer something more, a new kind of astronomy. For centuries, we've studied the universe with light. Visible light, radio waves, X-rays, gamma rays. But all of that relies on photons. Now, we listen to the universe with gravity. It is as if, after watching someone speak through a soundproof window, you finally hear their voice. You're no longer just looking. You're feeling. It opens doors. Doors to things we can't otherwise see. Black hole mergers leave no light, but their gravitational waves ring through the cosmos. And perhaps someday, we may even detect the waves from the Big Bang itself. A low, deep hum from the very birth of time. These primordial gravitational waves might still be rippling through us now, their song older than the galaxies, vibrating silently into the background. If we hear them, we could learn what happened in the first fractions of a second, when space inflated, when forces separated, when everything began. So you listen. You imagine lying not in bed, but on space-time itself. A vast, flexible sheet beneath your back, and you feel it. The faintest sway, the music of the cosmos reaching into your bones. It doesn't rush. It doesn't ask. It simply moves. Wave after wave, traveling through all things. A universe that sings. You wonder, now what else moves beneath perception? What other patterns lie beneath the surface? If space-time can ripple, can it twist? Can it swirl into knots? And if so, what forms might those knots take? Could they be woven into loops, into tiny threads, into the very foundation of reality? As you fall into rest, you carry this question with you. Not heavy, just glowing. Because next, we follow the waves into something even finer. Smaller than atoms, tighter than strings. We peer into the quantum grain of space itself, the loops beneath reality. You begin with a breath, the kind that feels like settling, like folding in. You're not shrinking exactly, but deepening, focusing inward, leaving behind galaxies, stars, and all the great roaring of space. You drift not upward, not outward, but down, into the subtle, into the silent, into the very threads of reality. You're looking not for atoms, not even for quarks, but for the shape of space itself, for the architecture that holds everything. What is space-time made of? Is it smooth? Is it continuous? Can it be divided forever into smaller parts? Or is there a grain to it? A smallest unit? A stitch? A loop? For much of history, scientists imagined space and time as a backdrop, a stage upon which the universe performs. They thought of it as a smooth, infinite plane, unbroken, unchanging. Einstein changed that. He showed us that space bends, that time stretches, that gravity is geometry in motion. But even his elegant theory, his curving, dynamic space-time, breaks down when you look too closely, too deeply. At the center of a black hole, at the first instant of the Big Bang, In these extreme places, the gentle curves of space-time become sharp, violent, infinite. And infinity is a sign, a whisper from nature that says, you're missing something. So we dig deeper. And one theory offers an answer as beautiful as it is strange. Loop quantum gravity. It begins with a bold idea that space itself is not smooth, but quantized. Just like matter comes in chunks electrons, protons, neutrons, and light comes in photons, perhaps space also comes in tiny, indivisible bits. These are not particles, not little balls or cubes. They're loops, tiny, trembling rings of pure geometry. Not things inside space, but space itself. Imagine a net, a web, a lace of loops stitched together into a structure so fine you cannot see it even with the most powerful microscope. Each loop is unimaginably small, about 100 million trillion times smaller than the nucleus of an atom. This is the Planck scale, the scale at which gravity, space, and time begin to behave not like smooth flows, but like quantum foam. Loop quantum gravity says that these loops weave space and time. Time is not a river. It does not flow. It is a series of transitions, moments when the loops shift, twist, connect in new ways. Time is change, and change comes in pulses and jumps, in beats, like a clock ticking. But so fast, so subtle, you feel only continuity. But beneath your perception, there is rhythm. The loops do not exist in isolation. They link. They form spin networks, a kind of scaffolding for all of space. Each node in the network holds a quantum of volume. Each edge between nodes holds a quantum of area. Volume and area, the building blocks of the world. And these loops do not sit still. They evolve. As the network changes shape, the geometry of space changes too. A kind of quantum choreography where the dancers are the stage. This is not an easy idea. It bends your mind in unfamiliar directions. You're used to thinking of space as emptiness, as nothing. But here, space is something with structure, something with presence. You imagine now floating inside a single loop, not to scale, but as metaphor. It is quiet here. The loop is not glowing. It does not spin like a planet. It simply is. It connects to others. A web of being without beginning or end. There are no coordinates, no up or down. Only relations, only links. And from these links, the illusion of space is born. Just as pixels on a screen become an image, just as notes in sequence become a melody, so too do these loops become the world. What does this mean for black holes? For the Big Bang? If space-time is made of loops, then perhaps singularities do not exist. There is no point of infinite density. Instead, there is a bounce, a rebound. In loop quantum cosmology, some physicists propose that before our Big Bang, there was a contraction, a universe collapsing inward, not into a point, but into a tight bundle of loops, which then reversed, exploded outward. A big bounce. It's only an idea, but it removes infinities. It restores hope. Even death may not be final. A black hole's core might crunch down, not to nothing, but to a loop woven. A Planck star. Dense, yes, but not singular. And one day, it might expand again, reborn as something new. You lie there, letting this idea drift through you. Everything woven, everything connected, Even space is not apart from you. It is you. Your thoughts stretch through loops. Your atoms ride the network. Your breath flows across quantum threads. You're not in the universe. You are the universe, woven into awareness. And there's one more thing. If space is looped, if time is granular, then perhaps the smoothness of reality is a kind of illusion. Like a film strip flickering fast enough to feel like motion. Like fabric woven so finely, you forget it's made of threads. And if everything is woven, can it be rewoven? Can the universe change its pattern? Do the laws of physics emerge from the dance of loops? Can they evolve? You begin to see space not as fixed, but as a living lattice. Dynamic, curious, expressive. And as you float there, nestled in quiet thought, you feel something else peace. Not because the world is simple, but because it is subtle. Not because you understand everything, but because you are part of something worth understanding. And now, as your breath slows, you begin to wonder. If space is made of loops, what makes the loops? What lies even deeper? Are there layers still unseen? Is there a code, a pattern, a hidden architecture beneath it all? What if reality is not just woven, but entangled? In the next chapter, you open that question gently, like unfolding a knot. The entanglement that binds everything. Close your eyes and let your body melt into stillness. You are no longer lying on a surface. You're held in a field, a lattice of soft tension, of threads you cannot see, but which feel as old as existence itself. Tonight, you drift into a mystery that startled even Einstein. A phenomenon so delicate, so strange, that it feels like magic until you look closer. It is called quantum entanglement, a term that sounds technical, but it means something simple and something wild. It means that two particles, no matter how far apart, can become linked in such a way that the state of one determines the state of the other instantly. Without a signal, without a cause you can trace. Imagine this. Two tiny particles born together in a single event. Perhaps from the decay of a parent atom, or the burst of a photon into twins. They fly apart, one to the left, one to the right, moving at the speed of light. You capture one, hold it gently, examine its spine, a kind of internal twirl, a direction, a yes or no. And in that instant, you know the spin of the other. Even if it is across the galaxy, even if no signal could reach it. This is not information being transmitted. It is not a message. It is a relationship written into the very state of being. Einstein famously called it spooky action at a distance. He didn't like it. It violated his sense of locality, the idea that only nearby things can affect each other. But the experiments kept repeating, over and over. Physicists created entangled particles, measured one, and saw the other respond. The effect was real. The world is not just made of things. It is made of relationships. Quantum mechanics doesn't just describe particles. It describes correlations. You begin to see this, not as a glitch in nature, but as its essence, a dance not of objects, but of connection. And this connection might be more than a curiosity. It might be the foundation of everything. Some scientists believe that entanglement builds spacetime itself, that the geometry of space, the curves, the distances, The dimensions you move through emerges from patterns of entanglement between quantum bits. The universe woven not from loops alone, but from shared memory. Like a tapestry that exists only because its threads are knotted together. You imagine floating through such a web, not caught, not bound, but held. The web stretches across the universe. It connects photons on opposite sides of the sky. It links electrons in your body to particles born in the furnace of stars. It touches you. Even now, your atoms hum with quantum vibrations. Inside each nucleus, fields rise and fall. Virtual particles flicker in and out. And sometimes those flickers are not alone. They mirror others. Your body, in ways too small to name, echoes with the universe. Entanglement does not violate causality. It does not allow faster than light communication. But it whispers that distance is not what it seems. That two things can be parts of a single whole, even when they are far apart. It is not a thread running between them. It is a unity written in duality, like two hands of one body, like reflections on opposite walls of the same flame. You may never see the connection, but you feel it. Now imagine this. Take a region of space, a small cube of vacuum. You'd think it holds little, maybe a few virtual particles, some quantum noise. But according to quantum field theory, even this empty space is alive with entanglement. The particles that flicker in and out are linked to particles just outside the cube. And the amount of entanglement grows with the surface area, not the volume. This is strange. It suggests that information and connection live on the boundary. This leads to something astonishing. The holographic principle. We've brushed it before, but now we feel its full weight. It says that everything inside a regional, the particles, fields, energies, can be described by data on the boundary of that region. Like a hologram, where a two-dimensional surface holds a full three-dimensional image. This idea is not metaphor. It emerges from deep theory, from black hole thermodynamics, from string theory, from entanglement studies. It suggests that reality, as you know it, may be encoded on a distant surface. Though what feels like volume is the result of entangled information stitched across a cosmic shell. You feel your mind tilt just slightly. What if the world you walk through, this room, this air, this night is a projection of deeper correlations? What if entanglement is the thread that draws time forward, that gives space its texture? Some physicists think that wormholes, those hypothetical bridges between distant points, may actually be built from entangled particles. That entanglement is geometry. That space, far from being a fixed stage, is made of whispers, agreements, shared being. You drift in this vision, letting it hold you. Not with answers, but with possibility. You feel how small you are, and not in the way of insignificance, but in the way of participation. You are a note in the music. Not the whole melody, but not separate from it either. And this is not just poetic. Entanglement has been tested, measured, verified. It fuels quantum computers, which rely on entangled qubits to perform calculations beyond the reach of classical machines. It enables quantum teleportation, where the state of a particle is transferred across space by entanglement and measurement. And someday, it may be the basis of unbreakable communication. Quantum cryptography, safe from all eavesdropping. But more than this, entanglement tells us something about the universe itself. That wholeness is fundamental. That division is an illusion. That the fabric of reality is a net of connection. And when you lie here, quiet, you can almost sense it. The air touching your skin, one's part of a distant cloud. The atoms in your bones, forged in hearts of ancient stars. The light from your screen echoing from electrons entangled with particles you'll never meet. You are part of this web. Always have been. Always will be. And so, you breathe slowly and rest into that thought. Entanglement does not need permission. It simply is. You feel the pull toward sleep, toward softness, toward surrender. But before you drift entirely, a new question flickers. If everything is so deeply connected, why do you experience life as separate? Is there a veil? A mechanism that hides unity and reveals only distinction? What if time itself is the answer? What if emergence is the process by which connection becomes experience? That's where you'll go next. To explore how space and time rise from entanglement and loops into the world you know. You begin in a quiet place, where breath deepens, where thought slows, where the world feels soft at the edges, as if it's still deciding what shape to take. Tonight, you're stepping into one of the gentlest puzzles in all of physics. A question not of what reality is made of, but how it appears, how it emerges. This is the story of emergence. How the complex arises from the simple, how the visible world grows from the invisible dance of the quantum. And it begins, as always, with noticing the chair beneath you, the floor, the air, the stars, the passage of time. They all feel real, solid, continuous. But you already know the truth is stranger. The chair is atoms. The atoms are mostly empty. The solidity is illusion. The air is fields. The fields are fluctuations. The temperature is collective motion. Time feels like a river. But at the smallest scale, it may be more like a clock ticking in loops. So, how do these illusions hold? How does the texture of everyday life arise from something so much more subtle? You start small. Think of a snowflake, its delicate symmetry, its six-pointed geometry, a marvel of natural design. But no single water molecule contains that design. The pattern emerges only when billions come together under the right conditions, bound by. From simplicity, complexity is born. This is the essence of emergence. And in physics, it may be the most important idea you've never heard of. Because it might explain why the universe looks the way it does, why space feels smooth, why time seems to flow, why gravity curves paths and matter clumps into stars. But beneath all that are systems that do not resemble their outcomes. There is no picture of a galaxy hiding inside a quark. Emergence is not magic. It's not creation from nothing. It's more like harmony. When tiny elements interact according to fundamental rules, they begin to sing. And from that music, a world arises. Take temperature, for instance. No single molecule has a temperature. It has energy is motion. But temperature only appears when many molecules come together, bumping and bouncing, exchanging heat. Consider pressure. Again, no single atom creates pressure, but a billion atoms in a container slamming into the walls that feels like force. Even color. The redness of an apple, that too is emergent, a response of your eyes and brain to certain wavelengths reflected by surfaces, formed by quantum bonds. So much of what you experience is not fundamental. It is layered. It is what emerges when the deep rules combine in certain ways. And now, apply this to spacetime itself. Could the geometry you move through up, down, forward, backward, the passage of minutes and hours, be emergent? Many physicists now say yes. That spacetime, the very fabric we've been exploring, may not be the deepest level of reality. It may be the result of something more abstract. Entanglement. Loops. Quantum information. Like pixels forming an image. Like code running a simulation. Like neurons producing consciousness. You return to the idea of spin networks, from loop quantum gravity, where loops of quantum geometry link together in a web. On their own, these loops don't resemble a room, or a planet, or a galaxy. But when billions of them connect, and change, and evolve, something astonishing happens. Space appears. Not suddenly, not like a switch being flipped, but gradually as relationships settle into stable forms. Certain configurations of loops give rise to volume. Others give rise to area. The more entanglement between parts of the network, the more space appears between them. Entanglement, connection, space. It's not just poetic. It's math. In this view, space is not where things are. It is how things are connected. And time may have emerged, not from a cosmic ticking, but from change. From the ongoing evolution of these quantum relationships. There is no master clock. No universal metronome. Time is what it feels like when loops rearrange, when information updates, when a before becomes an after. And gravity, that too, might be emergent. Some researchers propose that gravity is not a force, but an entropic effect, a result of systems trying to maximize their information. Imagine a rubber sheet. Place a bowling ball in the center, and the sheet curves. Not because the ball wants to pull, but because the shape that minimizes energy is a curve. Likewise, in entangled systems, mass bends space. Not because of a fundamental push, but because it's the most efficient arrangement of information. It's called entropic gravity. And while it's still speculative, it paints a vision of reality as an information engine processing, storing, evolving. You're not outside this. You're made of it. Your mind, right now, is a dance of emergent patterns. Neurons firing. Memories surfacing. Images flickering through. No single neuron holds your identity, but together, they create you. You are emergent, and yet you are real. So too with the universe. A vast emergence from countless small rules, playing out again and again. And like with any great emergence, there are thresholds, points where more becomes different, where quantity gives birth to quality. A single grain of sand is not a beach, but gather enough, and something new arises. Softness, landscape, place. One atom is not warm, but trillions in motion, like a summer breeze. Emergence builds bridges between the micro and the macro, between the loop and the planet, between the entangled bit and the curved sky. And it reminds you that nothing truly stands alone. The world is not made of isolated parts, but of interactions, of feedback, of story. Even consciousness, the quiet observer inside you, may be emergent, a product of complexity, arising from simple processes woven tightly together. You reflect on this as your thoughts grow slower or spacious. Emergence does not erase mystery. It deepens it. It asks not what is the world made of, but how does it know how to become? And that is a question you carry with you now, softly, like a shell pressed to your ear, offering the whisper of something vast. As you drift towards sleep, you feel the quiet miracle of being part of something that built itself from loops, from bonds, from change. And yet, there is one more layer still. If reality emerges from deeper patterns, might even those patterns be governed by something simpler? Could the whole universe be the unfolding of a single, elegant equation? Next, you rest your thoughts in that possibility, and you begin to wonder, what is the code that breathes? Let yourself grow still again. Let thoughts sink deeper. Tonight, your mind is not climbing. It's descending, down past what you can touch, past what you can name, past even the idea of a thing. You've already seen how space can emerge, how time might arise from change, how reality itself may be woven from loops, from entanglement, from rhythm and relation. But now another question opens softly, like a door you hadn't seen before. What writes the pattern? What tells the loops how to loop? What gives structure to entanglement? What teaches emergence to emerge? Beneath it all, is there a deeper structure? A rule that does not act, but from which all actions spring. Many physicists believe there is. They call it code, but don't imagine binary numbers or lines of text on a screen. This is not the kind of code humans write. It is not made of language. It is more like logic before logic, structure before form. Some call it the fundamental equation. Some seek it through string theory, others through quantum information. Still others turn to cellular automata-simple, rule-based systems that show how extraordinary complexity can unfold from basic steps. You pause now, letting that idea settle in your body. A code that breathes. Imagine a grid, just black and white squares. Nothing alive, nothing complicated. But add a rule, a single instruction. Something like, if a square has exactly 3 neighbors, it becomes white. If it has 2, it stays the same. Otherwise, it becomes black. That's all. Just a handful of words. Now, let the grid update again and again. What happens? Out of nowhere, patterns begin to form. Gliders, spirals, loops. Structures that move, reproduce, collide, recover. From nothing but a rule and repetition, a world emerges. This is the heart of cellular automata, and it may echo the way our universe works. Simple laws applied again and again at the tiniest scales, giving rise to galaxies, brains, consciousness, love. Stephen Wolfram, a physicist and mathematician, suggested that the universe itself might be one vast automaton, that what we see as particles and waves might just be the shadows of deeper computations running on an unseen substrate. It's a bold idea, but not unfounded. Quantum mechanics, after all, is full of rules, probabilities, patterns. Relativity is built from equations, as elegant as poetry. And information theory, the study of how bits behave, has become as foundational as matter or energy. What if the universe is not made of stuff at all, but of information? Not information in the way you use it, not facts or data, but structure, relationships, states, changes between states. You're no longer asking, what is the universe made of? You're asking, what is the instruction? What are the rules that make a particle, that make space curve, that make time move forward? It's possible, perhaps even likely, that all of physics can be derived from a single compact rule, a self-organizing principle, one that builds complexity, not by addition, but by iteration. Think of a fractal, like the Mandelbrot set, a shape made by feeding a simple equation into itself over and over. The result, infinite variety, unending detail, worlds within worlds, mountains, rivers, coastlines, trees, all appearing from feedback. What if the universe is a living fractal? What if the laws of physics are the visible petals of a recursive flower? You lie still, and your breath joins the rhythm. In, out, unfold. You wonder, if the code is so simple, why is the universe so rich? But that's just it. Simplicity, repeated, without end, does not stay simple. Add just one more dimension. Let variables interact. Let randomness flutter in, and the ordinary becomes beautiful. This is why physicists seek unification. They dream of one equation that explains all forces. Electromagnetism, gravity, the strong and weak, the nuclear interactions. A single expression that says, this is how the world builds itself. In the past, we found such patterns. James Clerk Maxwell, unified electricity and magnetism. Einstein, unified space and time. Later, quantum field theory, unified particles with fields. Each time, the layer fell away, and a deeper elegance emerged. And now, many look for a theory that unites general relativity and quantum mechanics. They speak of quantum gravity, of string theory, of loop networks. But perhaps all of these are just different dialects of the same underlying rule. Some call it the theory of everything, but that phrase is misleading. It's not everything. It's the seed, the breath, the code that becomes. You return now to yourself, to your body, to the quiet machine of you. Your DNA is a code, 4 bases, a spiral script. From it, every cell knows what to do, how to divide, how to specialize, how to repair. You're built from a rule, and your mind, it too is patterns, neurons, spikes, loops, a code running on a code, within a code. You are not separate from the universe. You are the universe's echo, its interpretation, its song. So you ask, what is the breathes? You're also asking, what am I? What breathes me into being? And there is beauty in not knowing, in wondering, in floating between answers, like a feather between winds. Perhaps the code cannot be written in human terms. Perhaps it is not digits, but difference. Not syntax, but flow. Perhaps it is silence that knows how to dance. As you rest, your mind does not need to grasp. It only needs to feel the rhythm. Beneath sensation, beneath emotion, beneath thought, there's structure. Not rigid, not fixed, but adaptive, curious. A breathing code, changing as it goes. Teaching itself how to be. And maybe, just maybe, that's what consciousness is. Not an observer of code, but the code observing itself. A mirror folded in. You are the question, and the language, and the one who listens. Now, as sleep approaches, you hold one last idea close. If everything is code, could reality be computed? Not in a computer, but by itself, running forward, self-sustaining. That's the next place we drift. A quiet space where physics meets computation. Where space-time becomes logic. Where the universe writes itself in real time. Next comes the simulation. That isn't a simulation. The thought arrives slowly. Not like a shock, but like a question you've always had, yet never asked aloud. Is the universe real? Or is it something being calculated? Generated moment by moment, like frames in a film, or tiles in a game. You've heard the idea before. The so-called simulation hypothesis. That everything you see, everything you touch, even your thoughts, might be the product of an unimaginably fast computer. Running a simulation so detailed, so deep, that the beings within it, like you believe, they're real. But tonight, you're not here to chase science fiction. You're not looking for glitches in the matrix. You're asking something quieter, more intimate, more rooted in real physics. You're wondering, what does it mean for a universe to be computable? Can nature run on rules the way a program does? Can the fabric of reality update itself bit by bit, state by state, with no master computer, only itself? This is not fantasy. This is the realm of digital physics, a field where scientists, philosophers, and mathematicians gather at the strange intersection of information, quantum theory, and computational logic. Let's begin slowly. Think of a game, a simple one, a world built of pixels, a space with physics, gravity, collision, motion. The entire world is generated by code, rules, logic. Every movement, every shape, an outcome of a programmed rule, executed on a loop. Now imagine zooming in, past the graphics, past the colors. What do you find? Bits. On, off, 1, 0. Every texture, every sound, every interaction all reduced to sequences of binary states. Now look at your universe. Zoom in, past molecules, past atoms, past quarks. What do you find? Quantum states, probabilities, discreteness. Not a smooth continuum, but a lattice of events. Each governed by strict rules, each constrained by the speed of light, by conservation laws, by logic. That is the foundation of digital physics. The belief that perhaps the universe is fundamentally discrete, that space and time come in tiny, indivisible units. Not pixels exactly, but something like them. Think of Planck length, the smallest measurable unit of space, or Planck time, the tiniest tick of the universe's clock. Below these scales, current physics cannot resolve anything more. It's as if reality itself has a resolution. And just like a video game, does not simulate every pixel on the screen until it's needed. The universe may not calculate every particle's position until it's observed, until it matters. You've already met this idea in quantum mechanics. The wave function. The role of the observer. The collapse of possibilities into actuality. Some physicists suggest this is not coincidence. That reality's behavior is not just wave-like, but computational. That it does not waste effort on unnecessary calculations. This brings us to computational irreducibility, a concept introduced by Stephen Wolfram. It says that for many systems, the only way to know what comes next is to compute each step. There is no shortcut, no equation that jumps to the end. The universe, then, is not solved. It is run, like a clock ticking. One moment birthing the next, all governed by simple rules that cannot be sped up, only followed. This doesn't mean the universe is fake. It means it is self-calculating. A natural computer that does not sit on a desk, but spans all of existence. In this view, you are not a line of code. You are a result of the code, a structure made of emergent interactions. Deeply real, because the rules give rise to the possibility of meaning, of experience, of memory. And what of time and computation? Time is built in. Instructions follow one another. One state becomes the next. So too, perhaps, in the universe. Time may not be a river. It may be the process by which the system updates from one configuration to another, from past to present to future, all as a function of rule-based transition. Does that sound mechanical? Maybe. But remember, beauty lives in process. Just as music arises from simple notes played in rhythm, so too might reality arise from logic unfolding in perfect timing. So why, you ask, does the simulation idea get so much attention? Because it's a mirror. It reflects the truth that reality is deeply ordered and yet mysterious. And perhaps because the idea that everything is code makes some people feel displaced, as if being simulated makes them less real. But not you. Not tonight. You understand something gentler. That if the universe computes itself, then that computation is not separate from experience. It is experience. You are not outside a system. You're not a character in a game. You're a fluctuation within the process. A self-aware configuration in the network of laws and loops. No puppet strings, no puppet master, just emergence, self-reference, being. And here's something lovely. In some models of digital physics, space can be thought of as a graph, a network, nodes and edges, like neurons, social systems, like ideas. The relationships between nodes define the structure of space. Distance is not absolute. It is the number of links between points. Think of your relationships to others, to yourself. They too define how close or far you feel. Perhaps the architecture of reality is not just mathematical, but emotional. And if this world runs on rules, does that make it less magical or more? You begin to wonder if every breath you take is part of the universe computing itself forward. If every thought you have is a state transition. If love, pain, hope are outputs not of machinery, but of logic deep enough to birth meaning. There is elegance here, not cold, but quiet. The code that computes the sky also computes the warmth of a blanket, the hush of falling asleep. You are part of it, not plugged in, not uploaded, just here, in the middle of the system, feeling, Tonight, you rest not in doubt, but in wonder. Not because the universe might be simulated, but because it might not need to be, because it can compute itself from nothing but law, pattern, relation. And because that computation does not reduce you, it includes you. And you are the loop that knows itself, the code that dreams. And tomorrow, you will explore something even softer. How memory moves through space-time, and what makes causality feel so firm. But for now, you fall into the stillness between calculations. The tick before the next talk. The place where something becomes. Next comes causality, the arrow that points through time. Let the world soften again, but your body feel the stillness beneath it. A sense of grounding, like a rock resting at the bottom of a still pond. Tonight, you're not rushing anywhere. You're not trying to solve anything. You're simply here to drift gently down a line you followed all your life, without ever turning to see what it truly is. That line is time, and its direction, the way it always seems to move forward, never backward, is what physicists call the arrow of time. You feel it even now, in the settling of your breath, in the progression of thought, and the way each word you hear becomes memory, never to be unspoken. But pause here. Ask yourself softly, why does time have a direction at all? The laws of physics, the ones that govern motion, light, gravity, even quantum fields are almost all time-symmetric. Meaning, if you ran the equations backward, they would still work. If you watched a planet orbit in reverse, the math would make sense. If you reversed every motion, reversed every spin, even reversed the paths of light physics, would not object. And yet, you've never seen a shattered cup leap back together. You've never unbreathed a breath. You remember yesterday, but not tomorrow. So where does the arrow come from? To understand, we begin with something familiar and surprisingly powerful: entropy. Entropy is the measure of disorder, but not in the messy sense, not like socks on the floor or tangled hair. It is a measure of how many microscopic ways a system can be arranged without changing what it looks like macroscopically. A neat row of books has low entropy. Toss them randomly into a bin. Higher entropy. More possible arrangements. The second law of thermodynamics, one of the most robust principles in physics, says that entropy tends to increase. Left alone, systems move from order to disorder, from neatness to randomness. A drop of ink in water spreads. A hot cup of tea cools. Ice melts. And in each case, the process only goes one way. That direction from low entropy to high is what gives time its arrow. Entropy grows, and time moves forward. They are two sides of the same idea. You're not imagining it. There is a reason the past feels different from the future. The past has structure, a lower entropy starting point. The future holds more possibility, more ways for things to be. And you're made of entropy gradients. Your body digests food, burns fuel, releases heat. Each action increasing entropy. Even memory itself, the sense of before and after, relies on change. Neurons shifting. Connections strengthening. You remember the past because it left a trace. But the future is untraced, unwritten, still unfolding. Now imagine the universe at its birth. According to current cosmology, The early universe, right after the Big Bang, was incredibly hot, dense, and surprisingly low in entropy. This puzzles scientists. Why would the universe start in such a rare, ordered state? No one fully knows. Some think it's a boundary condition, a rule written into the origin. Others think time itself is emergent, and the direction we experience is tied to our limited view within the cosmic unfolding. But from that low entropy state, everything flows outward. Galaxies form, stars burn, life arises, thoughts appear. And with each passing moment, entropy increases. The arrow stretches further. You feel it in your bones, this directionality. Even in rest, your body ages. Cells divide. Time presses forward. But here's something strange. At the quantum level, things are fuzzy. Particles don't behave like tiny billiard balls. They are waves, probabilities, tendencies. A particle might go one way or another until it is measured. Then it collapses into a state. But in the equations, whether for electrons or photons, there is no preferred direction in time. So why don't we see reality playing out backward? The answer may lie in correlation. When systems become entangled, as in quantum mechanics, they develop relationships. If one particle does this, the other does that. These correlations, once formed, are hard to reverse. You can scramble an egg, but not unscramble it. Even if every molecule could be individually reversed, and in theory, you would need to undo all the entanglements with the entire universe. It's not impossible in theory, just infinitely improbable. So time flows, not because it must, but because it's the path of least resistance. You drift now through this idea, a universe where cause leads to effect, not because of fate, but because of statistics. The future is a vast landscape of possibilities. The past is a narrow, frozen road already traveled. And in between, you stand. You might think of time as a river, but in physics, it's more accurate to see it as a dimension. Like space, it can be described mathematically. A coordinate. Einstein taught us this. In spacetime, events are points. You, reading this sentence, a point. The birth of the moon, another point. From the outside, all of history could be seen as a whole, a complete block. But inside that block, your experience of time is like a traveler moving through it. Why do you go one way? Because you're made of systems that record, process, and respond to change. Because your body, your mind, your world are embedded in entropy. Because the arrow of time is not imposed on you. You are woven from it. Even consciousness flows this way. A self that remembers, but cannot remember. A being that expects, that leans into tomorrow. It's beautiful in its simplicity, and even more so in its mystery. You close your eyes and feel the weight of causes behind you. Stories, choices, the subtle cascade of all that led here. And ahead, not destiny, just openness, unfolding. You do not need to control it, only to witness it. And trust that the arrow, gentle as it is, knows how to carry you forward. From sleep to waking. From now to next. And as you drift, you begin to wonder, if time flows one way and space can bend, then what happens at the edge of speed? What do time and space become when stretched near their limit? Next, you travel toward that question. where velocity slows the clocks and time itself stretches into paradox. Next comes the edge of time, moving closer to light. There is hush in the dark tonight, a deeper stillness, like the quiet before something shifts. And in that stillness, you feel something begin to stretch. Not your body, not your breath, but time itself. It doesn't snap or break. It elongates softly, imperceptibly. Tonight, you are going to the edge of time, not the end of it, but the edge where time behaves differently, where it warps, bends, stretches. And to understand that edge, you must begin with motion. Imagine two people, one standing still, the other on a fast-moving train. They both carry clocks, perfect atomic clocks, ticking away in silence. When they meet again and compare those clocks, they are not the same. The clock on the moving train has ticked fewer times. Time itself ran slower for the one in motion. This is not fantasy. It's not just theory. It's time dilation. One of the most beautiful consequences of Einstein's theory of special relativity. Let that sink in. Motion slows time. Speed changes the flow of reality. The faster you move, the slower time ticks for you relative to someone who is still. And at the speed of light, time would stop altogether. But you'll never quite reach that speed. Because if you have mass, any mass at all, you cannot move at light speed. To do so would require infinite energy. Still, you can imagine. In your mind, you drift toward that unreachable line. Let's walk more slowly through this. Imagine you're in a spaceship. At first, you glide gently away from Earth. Your engines hum lightly. The stars ahead look still. The ones behind slowly receding. But you accelerate gently, then faster. Soon, you're moving at a significant fraction of the speed of light. What changes from your perspective inside the ship? Nothing feels unusual. Your pulse, your thoughts, your breath, they all seem normal. Time feels the same to you. But to someone back on Earth, time is passing faster. Much faster. Maybe a day has passed for you, but a week for them, or a month, or a year. This isn't a trick of perspective. It's measurable. It's real. And we've confirmed it with satellites, with high-speed particles, even with synchronized atomic clocks flown around the world. It's not just time that changes. Length contracts in the direction of motion. Mass increases. The faster you go, the more warped reality becomes. This isn't just about space travel. It's about the shape of reality itself. Because time and space are not separate things. They are woven together. A four-dimensional fabric called spacetime. And when you move quickly through space, you move differently through time. This is why light is so strange. It does not experience time. A photona particle of light leaves a star, travels for billions of years, and strikes your eye. But from the photon's own perspective, no time has passed. There is no before, no after. It just is. A flicker of existence between 2 points. You can't really imagine that, but you can feel its edges. Because the closer you move to light speed, the more your world begins to behave like light's world. Distances shorten. Time slows. If you could reach 99% of the speed of light, time would slow to a crawl. Years could pass on Earth, while only hours pass for you. Push further to 99.9, and the difference becomes enormous. You could travel thousands of light years and return to find your planet transformed, perhaps even gone, and you, barely older than when you left. This is not fiction. It is physics. Confirmed, tested, real. This gives rise to the idea of the twin paradox. Two twins. One stays on Earth. The other travels in a near light speed ship. When they reunite, the traveling twin is younger. Not because of illusion, but because of reality. Time bent for them. The arrows stretched thin. Now rest in that image. Two people, once born together, now separated by time itself, by the shape of motion. This is where time reveals its fluidity, where the ticking of clocks is not universal, but relative. Heart, you know it. Even as science pulls time apart, questions it, tests its nature, you live it. You remember, you anticipate, you change. And that, perhaps, is what time truly is, a measure of change, a rhythm of the universe, felt in the breath of stars and the slowing of clocks. Now you're nearly at the edge of light speed, the edge of time. It's not a wall, it's a boundary of understanding. A whisper that says, this far, but no further. Light is the speed limit of the universe. Not because of technology, but because of reality's shape. It's the line beyond which time turns still, and motion becomes pure being. You float there now, just beside that line. Time slowed, body light, mind quiet. And you wonder, what happens after this? If motion slows time, what would it take to stop time entirely? Reverse it. What strange landscapes lie beyond the limit, in the realm of black holes or deep cosmic expansion? What does it mean when space itself begins to stretch faster than light? That question opens gently, and it leads you toward your next dream, where distance becomes elastic, where the universe inflates, where nothing can catch up. Next comes the expansion that outruns light. Let your breath fall into rhythm again. Let your body grow heavy with calm. Outside your window, the night might feel still. But across the universe, everything is moving. No stars are truly frozen. No galaxies are truly anchored. Even now, space is stretching softly, invisibly, quietly. Not pushing things through space, but expanding the space between them. And here's the wonder. Some of that expansion moves faster than light. Not because the galaxies themselves are racing, but because the fabric they sit on is being pulled outward. Tonight, you drift into this grand unraveling, a cosmic quiet where even light can no longer keep up. Begin at the beginning, as softly as time allows. The universe was once very close, a dense, bright place. All matter, light, and space compressed into a state so hot that it was almost featureless. And then, expansion. Not an explosion, but a stretching, cooling, a becoming. The Big Bang is not a moment of chaos, but a transition of scale. And ever since that earliest moment, space has been growing. Galaxies, stars, planets, they're not racing away through space, like sparks from a fire. Rather, the space between them is growing. Picture dots on a balloon as it inflates. The dots don't move themselves, but the surface expands. And with it, each dot becomes further from the others. Now imagine that balloon in all directions, not just outward, but everywhere. A three-dimensional stretch, without a center. That's the universe you live in. An expansion not from a place, but of place itself. And this brings you to the mystery of cosmic speed. Light has a limit, 300,000 kilometers per second. Nothing with mass can exceed it. But space is not made of particles. It does not carry energy in the way objects do. So it can, and does, at rates that exceed light speed. At great enough distances, galaxies are receding from you faster than any signal can reach them. They are not moving through space. They are being carried by space. It's like trying to run up a down escalator. That gets longer as you move. No matter how fast you run, the ground beneath your feet stretches faster. Eventually, the top fades from reach. And this is happening right now. Not to one galaxy, but to trillions. The cosmic horizon, the limit of what we can observe, is not fixed. It grows, and yet it recedes. Because some things drift beyond into regions where light will never return to us. You live in a universe with a visible bubble, a sphere of stars and history, about 46 billion light years in radius. But beyond that bubble, things continue unseen, untouchable, expanding into silence. This brings us to a deeper question. Why is the universe expanding so fast? Why is it accelerating? You'd expect gravity to pull things back in, to slow the growth. And it did for a while. But something changed. In the late 20th century, astronomers noticed something. Distant supernova, the exploding deaths of massive stars, were dimmer than expected. They weren't just far away. They were more far away than gravity alone could explain. Something was not slowing the expansion. Something was speeding it up. They called it dark energy. Not because it was understood, but because it wasn't. An unknown force, an invisible pressure, woven into the vacuum itself. Dark energy makes up nearly 70% of the total energy in the universe. It does not clump. It does not dilute as space grows. Instead, it seems to act as a property of space. The more space there is, the more dark energy appears, and the more space expands. It is a feedback loop that pulls galaxies apart, even as gravity tries to hold them close. And this isn't some distant future. It's now. Right now, the universe is expanding faster than it ever has before. And with each passing moment, more galaxies drift beyond our reach. Eventually, if this acceleration continues, even the nearest galaxies will fade from view. Billions of years from now, an observer in our galaxy might see only darkness. No signs of the Big Bang. No cosmic microwave background. No other galaxies. Just silence. Just stars within the local cluster. The universe will become lonely. But don't let that make you sad. Because this expansion, this quiet running away, has beauty in it. It creates space for change, room for stars to be born, for planets to cool, for life to arise. Without it, everything would have collapsed back into the heat and tightness of the beginning. Expansion gives time its chance to unfold. And in the vastness it creates, your existence is a kind of bloom. A local slowing, pocket of complexity, in a world that wants to stretch. Now rest in this image. You're riding on a galaxy that moves not through still space, but on expanding space. Like a leaf on a rising tide, you drift outward, not alone, but part of the motion of everything. The stars you see are not fleeing, and they're steady. It is the space between them that slides wider. Every second, more universe. Every moment, more distance. And that distance, that silent drift, one day separate you from nearly all the cosmos. But right now, you are connected. You can still see light from the dawn of time. Still feel the echo of that first warm breath when space began to unfold. You're here, inside the living expansion. Not watching from outside, but woven into it. Not resisting the drift, but resting in it. There is peace in knowing. You don't need to outrun it. You don't need to fight for stillness. Because expansion is not chaos. It is a rhythm, a breath, one that carries you gently toward the next mystery. And as the galaxies drift away, you may wonder, what happens to information when things move too far apart? Does knowledge fade? Can anything escape the boundary of expanding space? What happens, in other words, when light is not fast enough? And that thought brings you to the next threshold, where black holes whisper, where nothing, not even light, can turn back. Next comes the event horizon, where information slips away. Close your eyes. Let gravity settle into your bones. The gentle pull that keeps you anchored. Feet to floor. Breath to earth. It is familiar. It is soft. But tonight, you will visit a place where gravity becomes something else entirely. It becomes a wall, not made of stone or energy, but of inevitability. This is the event horizon, the edge of a black hole. And beyond it, not even light can escape. Beyond it, information seems to vanish. And yet, you begin here, hovering just at the edge, suspended in thought, drifting on the brink of what can be known. To reach this place, you must first understand gravity's hunger. Imagine a star, many times more massive than your sun. It burns brightly for millions of years, fusing the hydrogen into helium, helium into heavier elements. But one day, its fuel begins to run out. The outward pressure from fusion can no longer hold up against gravity's inward pull. The star begins to collapse. Not slowly, not gently. The core crushes inward until atoms themselves are broken. And if the mass is great enough, nothing can stop the collapse. Not atoms, not light, not even space itself. The core becomes a singularity, a point of infinite density, not a place in space, but an end of space. And around this singularity, a boundary forms, not a surface, not a shell, but a horizon, the event horizon. It is not dangerous to touch. Not in the way a flame or a blade is. You would feel nothing crossing it. No warning, no flash. Just the knowledge that once you passed, you could never come back. It is the point of no return. If you sent a friend towards the black hole and watched from a distance, you would see them slow. Their clock ticking slower and as they approached the horizon. Their signals would stretch longer and fainter, until finally they'd freeze in place, fading to red, then to black. You would never see them cross. But they would. From their view, they would drift across the horizon, an heartbeat. What lies inside? No one knows, because no information can leave. No signal, no light, no data. And yet, this creates a paradox, a question that shakes the very structure of physics itself. What happens to the information? When something falls into a black hole, a book, a planet, a person, their physical form is gone. But the laws of physics say that information cannot be destroyed. Even if you burn a book, its atoms scatter. The ink, the smoke, the heat all still contain the story, hidden in complexity. But a black hole, it erases the details. Or does it? This is the heart of the black hole information paradox, and it has haunted physicists for decades. Stephen Hawking, in the 1970s, introduced a stunning idea. Black holes can radiate. Over time, they emit tiny amounts of heat, called Hawking radiation, caused by quantum fluctuations at the edge of the event horizon. This radiation carries no trace of what fell in. So, over billions of years, the black hole evaporates. And then what? If it disappears completely, where does the information go? Did the universe just lose part of its memory? That can't be. Quantum mechanics forbids it. And yet, general relativity demands it. You see the conflict now. Two pillars of modern physics grinding against each other in the shadow of the horizon. The mind wants resolution, but the universe, it whispers contradictions. Some physicists believe the information is smeared across the horizon, encoded in a two-dimensional surface, like a cosmic hard drive. This idea gave rise to the holographic principle, the notion that all the information about a three-dimensional region might be stored on its boundary, like a hologram, where depth is an illusion, encoded in a flat image. If true, then your universe itself might be a projection from a deeper layer. Others argue that black holes never truly destroy information, but scramble it in such a way that it becomes unrecoverable. Like ink dropped into a stormy ocean still there, but forever lost to human tools. Then there are newer, stranger ideas. Firewalls, fuzzballs, quantum air. Each an attempt to reconcile gravity and quantum law, but none fully satisfy. And here you are, suspended at the event horizon, wondering about truth. Not the kind in textbooks, but the quiet truth of falling into the unknown. You imagine a particle, simple, small, a whisper of matter, drifting toward the edge. As it crosses, its fate becomes sealed. And yet, its story, its momentum, its vibration, they matter. They are part of the fabric. They cannot simply vanish. Maybe they ripple outward. Maybe they encode themselves in the stretching of space. Maybe they become something else. In this quiet, you feel time slow again. The gravity here is so intense that time itself bends. Minutes stretch, hours freeze. And as you hover near the edge, you sense a deeper stillness, a silence that feels like the breath before a thought. You wonder, what would it feel like to fall in? Not as a person, but as awareness. As a trace of self, becoming part of something vast. Would you dissolve? Would you stretch into forever? Would you find something timeless inside? No one knows. And maybe that's the gift of the event horizon. It is not just a limit of space. It is the edge of knowledge, the place where physics, philosophy, and imagination meet. And where, perhaps, the act of not knowing becomes its own form of peace. You float there now, not falling in, not pulling back, just listening to the silence, to the gravity, to the not knowing. And slowly, you begin to sense that even here, at the edge of loss, there is something persistent. A whisper of pattern, a ripple of memory, a suggestion that what disappears may still be part of the whole. The universe does not waste. It does not forget. Then maybe neither do you. From this edge, you will drift toward the final chapter, where all the threads meet. Space, time, motion, and meaning. Not to find an answer, but to rest in what remains when time itself dissolves. Next comes timeless. You followed the thread through every curve, every wrinkle in the fabric of spacetime. From the stillness beneath everything, to the expansion that outruns light, to the edge of black holes and the fading warmth of distant galaxies. Now you arrive here, where time no longer leads. It simply rests, silent, spread out. Tonight, you drift into the space between moments, into the place where time itself may end, or where it never truly began. Let your breath slow. Feel the heaviness of your body melt into the mattress, into the floor, into the earth that spins silently through the dark. Time feels simple to you. It ticks forward 1 second after the next. You're born. You age. You remember what was and anticipate what will be. But what if that flow is only a sensation? What if time is not a river, but a landscape one you're walking through, step by step, page by page? Imagine a book already written, every chapter bound, every word inked, but you can only read it in order. You feel it as unfolding. But in truth, all the events exist at once, waiting to be read. This is the idea of block time, the past, the present, the future. Not separate, but equally real, equally alive. Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." And here, in his final chapter, you feel the illusion ease. You are no longer rushing forward. You are pausing, letting the whole timeline spread out around you. So, what is time, really? Is it movement? Change? Is it tied to entropy, the measure of disorder? Some scientists think the arrow of time is born from entropy. A broken egg does not unbreak. A cold cup of tea does not warm itself. Memories form only after events, not before. And yet the laws of physics do not prefer one direction. At the quantum level, processes are often time reversible. Equations work just as well forward or backward. So, where does our one-way experience come from? Why does the future feel open and the past feel fixed? Some say it's because the universe began in an extraordinarily low entropy state, a place of great order from which chaos could grow. And with it, the arrow of time, like a wind blowing from order to disorder, from smooth to complex, from early to late. But you're not bound to arrows tonight. You lie here between thoughts, between events. And to ask yourself, is it possible to experience time differently? Consider the photon, a particle of light. From its own frame of reference, no time passes. It is emitted. It is absorbed. There is no during, no wait, no travel. What feels to you like a journey light from a star traveling billions of years feels to the photon like no time at all. Timelessness. At the speed of light, the dimensions of time dissolve. You also saw it at the edge of black holes, where time stretched near infinity, where 1 minute could contain 1,000 years. You saw it in cosmic expansion, where space carried galaxies beyond your reach, locking light in place, slowing clocks beyond imagining. All these whispers suggest that time is not universal. It is personal. It is local. It is part of how you experience the unfolding of the universe, but not how the universe is. So then, what remains when time is gone? Consciousness, presence, something like awareness without narrative. Can there be memory without a timeline? Change without a before and after? Here's another idea. A soft one that doesn't demand an answer. Time may be a property that emerges. Not something built into the universe, but something that arises from entangled particles, from thermodynamics, from the way you observe and are observed. Like sound emerging from air molecules, like waves on the surface of a sea. The universe, at its root, may not tick. It may simply be. And your brain, woven of matter and memory, constructs time to make sense of motion, cause, and life. You create time as you go. And in dreams, you sometimes feel that truth. When minutes stretch into hours, or years pass in a single blink. Time is not your jailer. It is your painting. You place yourself inside it. You choose colors of memory and desire. You move your brush slowly and name the result a moment. But tonight, you set the brush down. You let the paint dry. You let yourself step outside story. Outside of sequence. Outside of clock. And there's only presence. No goals. No next. No measurement. Just the hum of blood. The echo of thought. The soft weight of now. Maybe this is what the universe feels, beneath all the stars, beneath the motion and expansion. A kind of eternal quiet. Timelessness is not the end. It's the return. Like silence after music. Like the pause between breaths. Like a space between heartbeats. That reminds you you're still here. Tonight, you've traveled far. Through quantum foam and cosmic horizons. Through particle and paradox. You've seen how light shapes time, how gravity slows it, how space stretches it thin. You felt the beginning of everything, and the still hum beneath space-time. And now, you rest at the center of all of it, not watching the universe move, but becoming the still point it moves around. Because maybe time is not something you run through. Maybe it is something you return to, over and over. And maybe sleep is the closest you come to timelessness. A dissolving of narrative, a soft falling inward. So go now, not forward, not backward, but inward, into the stillness that made the stars, into the fabric that holds the story, into yourself. Let go of time and sleep. If you've enjoyed this journey through the fabric of space-time, I'd be honored if you gave this video a gentle like and subscribed for more soft science stories like this. You can also support the channel through Super Thanks or by joining our sleepy little membership, which helps me create more of these calming explorations for curious minds like yours. And if you're still awake, let me know in the comments what part of space-time you found the most fascinating. Wherever you are, whatever time it is, Thank you for dreaming with me. Stardust. Timeless.